medical officers who are doing general knowledge examination. So we'll do that. I hope you can see the screen. Okay. Okay. I hope you can see the screen. So statistics, basically, statistics is the subject. Now anatomy, anatomy is a subject for to learn about human structure. Physiology is a subject that we learn human physiology. Likewise, statistics is subject that we are learning about variability. Variability is a phenomena of changing the observations from one to another. So, in statistics, the first concept that we need to learn is variables. In variables, I mentioned you variability is a phenomenon of changing one observation to another observation. If you think about your Excel sheet, now in the Excel sheet, there can be several students. We name them A, B, C, D, E. In the next column, we might have the height, 116, 117, 120, so like this. And the next one may be the BMI. So BMI might be 20, 16, 17, 23, so like that. So we can measure their the most preferred color, maybe red, blue, green, so like that. Now variable is just one column. So now this column indicates the height. So that is height variable, and this column is the weight. That is a weight variable, and this one is preferred color. That is a color variable. So you can see the variability is changing. The observations are changing from one to another. So the height is different from A to B. Weight BMI is different from A to B. So like that, the preferred color is also different. So that is what is called, those are the variables. The next thing is how do we categorize variables? Right? How do we categorize variables? The main method is qualitative variables and quantitative variables. Qualitative and quantitative. In MCQs, I have seen basically sometimes they do not use the word term qualitative, and some they don't use the term quantitative. They use the word for qualitative variables, they use the word categorical. And for quantitative ones, they use the term numerical. Categorical and numerical, right? Categorical variables in MCQs, they might not purely use this qualitative or quantitative, they might use these things. And if you are using something like statistic at a glance, they have a different description. I think that is again wrong. So qualitative variables may be things like color, preferred type of car, so like that, qualitative variables. In quantitative variables, the things I discussed like height, weight, BMI, maybe drug dose, so like that, quantitative variables are different. But in statistics, rather than this qualitative and quantitative variables, the most important categorization is discrete or continuous variables. If you are taking down the notes, this is especially for the online participants. If you are taking down the notes, please write quickly because I'm going to erase. I have to do like about 48-hour session within 5 hours, including the MCQs. Okay. The next one is the main categorization method is discrete and continuous. Discrete variables and continuous variables. In discrete variables, these are generally quantitative variables. Now, in statistic at a glance, they mention that discrete are the ones qualitative, which is wrong. Discrete are not exactly qualitative, right? And continuous ones, they are quantitative. That's true. Discrete also, it's kind of quantitative. I will explain this. If you give an interval, for example, of human height may be 100 and ranges from 130 to 200 centimeters. In this interval, right, anything is possible. In this interval, anything is possible. Anything is possible. That means continuous variables. Yeah, in a given interval, any value is possible. For example, there might be people like 155.6.6.7.8 like that. Any value is possible, right? So those are the variables known as continuous variables. Examples are height, weight, like that. But discrete variables are the ones in a given interval. Only fixed number of possibilities are there. Generally, there are no decimals. No decimals. Or even though there are decimals, still the possibilities are fixed. For example, number of days of hospital stay. So now number of days we can have half, but generally we count. So either it has to be like 4 days, 1 day, 5 days, something like that. Only fixed values are possible. Number of children in a class. Number of children in a class. So we cannot have 29.6 students in a class. So decimals are not possible. So this kind of variables are known as discrete variables, while continuous variables in a given interval, any value is possible. In a discrete one, anything in a given interval, any only fixed number of possibilities are there. Both are quantitative. Generally, yes. The thing is, now the question from the physical audience. That is the advantage for the physical audience. We will give some refreshments, and they have a chance to ask the questions. And the question is about whether discrete and continuous both are qualitative. The answer is quantitative. Whether both are quantitative. The answer is it's a different categorization. The reason is, now if we think like that, the preferred colors, I hope you can see. Colors, this is a qualitative variable. Colors, blue, green, red, right? And we do this study among the doctors in the hospital. And blue, green and red. Blue, 66 doctors prefer blue. Green, 50 doctors, and red, 70 doctors, something like that. That is the preference. Of course, the number of here, this is a discrete variable. Number of doctors who prefer color, but colors is of course a quantitative variable, and this one is discrete variable. So discrete and continuous is a different categorization rather than qualitative and quantitative. Qualitative variables can be in the form of discrete variables because we are counting them. Discrete variable we count, continuous variable then we measure, right? Actually, for the MCQ, so that's enough. That is enough. I need to mention a few things more about discrete and continuous variables. The thing is, Discrete variables generally they don't follow the normal distribution. Either they are negatively skewed or they can be positively skewed. Either positively skewed or negatively skewed. Generally, for the negatively skewed means skewed to left side, because the tail is towards left or negative side, and here the tail is towards positive side, and we call it skewed to right. Discrete variables generally skewed, but remember, not all discrete variables follow this skewed shape. There can be discrete variables which follow the shape of which gets the shape of normal distribution as well. Continuous variables generally take the shape of normal distribution. Right? But keep in mind, it's not all. Generally, they are biological variables, such as height, weight. But if you think about income is a continuous type variable, but income what happens is income is positively skewed, because so as the government thinks, doctors and only few of the people are in the 10% salary scale. We are getting so much of money, and because of that, income distribution is positively skewed. But it's a continuous variable. If you think about harvest again is skewed, because the minimum amount of harvest that we can have is 0, but the maximum we can have many numbers. Rainfall, again the minimum is 0, maximum is it's a positive tail. So even though they are harvest and income, those are the examples of continuous variables which takes the shape of skewed distribution. And again, I got a question in the chat box. If they ask about whether weight can be skewed, yes. The thing is, I cannot say that everything is normal, but if the sample size is adequate, it's more towards normal. But all distributions, there can be even biological like height, which takes the shape which can be skewed. But keep in mind, this discrete variables, skewed, continuous, normal, this categorization is, if you know this categorization, it's like you know all the stuff in statistics. Keep in mind this thing, keep in mind, this will be important. Okay. The next thing is, now, assume that we have a class, we have 30 students, 1, 2, 3, 4, 5, like 30 students, and we have their marks for mathematics, maybe mathematics, first 100, 98, 93, 86, like that. The 30th students might have 78. So like that we have set of students. How do we summarize this data? How do we summarize? If somebody asks, how's the marks in the class? How's the marks in the class? How do we summarize data? What the marks summarize? The first method that we can tell is, we can tell පළවෙනි ළමයට 100යි 98යි මෙයාට 93යි මෙයාට 86යි ඒක කියන්න පුළුවන්. එහෙම නැත්නම් අපිට කියන්න පුළුවන් අපිට සමරයිස් කරන්න පුළුවන්. The first method of summarizing is, we call that measures of central tendency. Measures of central tendency. There are 3 measures of central tendency that we know. You all know those things. අපි දන්න තුන තමයි අපි දන්නේවා mean, median and mode. mean, median, and mode. Mean, median, and mode. Right? So if I recall you, mean can average, we have to divide knife. Now we have to add all the marks like 100 plus this one plus everything and divided by the total number of students. Median, we put them in the ascending order. That is important. From the smallest number to largest number, and we get the mid value. We call that the 50th centile, or the mid value is the median. Madhyastha, and mode is the most. Mode කියන්නේ මාතය කියන්නේ වැඩිම වාර ගණනක් තියෙන highest most frequent number in the distribution. So those are the measures of central tendency. The measures of central tendency. And another important thing I need to highlight is, now assume that this is a normal distribution. It's a normal distribution. Generally, in a normal distribution, now we are going to talk about the properties of normal distribution. If a distribution is normal, we know that mean, median, mode, all three are at the center. All three are at the center. And if you can remember your statistics, this is 1 SD and this is 2 SD and this is minus 1 SD and minus 2 SD. Right? In a normal distribution, this range, that is mean plus or minus 1 SD, mean plus or minus 1 SD will consist 68%, approximately 68% of the participants. Approximately 68% of the participants. Normal distribution. And in the meantime, we will put some video recorded lectures, because this will be a 4-hour session, and we are going to discuss about like 50-hour or 100-hour 2 modules within 4 hours. So if you need some detailed explanations, we will put the recorded lecture in the chat box, so you can go to that YouTube channel and see the get some more explanation regarding this. And the next one is mean plus or minus 2 SD limit. All this area, mean plus or minus 2 SD, will consist of 95.5% of the individuals. Somebody might ask whether we need 0.5%. The answer is yes, because there were some MCQs from this 0.5%. Mean plus or minus 2 SD will consist with 95.5%. And the next one is mean plus or minus 3 SD will consist with 99.7% of the participants. These are the properties of normal distribution, right? And if I summarize everything like this, mean plus or minus 1 SD, mean plus or minus 1.96 SD, mean plus or minus 2 SD, mean plus or minus 2.59 SD, mean plus or minus 3 SD. Right? This will have approximately 68%. 1 plus or minus 1.96 SD will have 95%. That's why 2 SD will have 95.5%. And mean plus or minus 2.59 SD. I think one of the MCQs in past papers, I cannot remember the exact, they have asked about mean plus or minus 2.959 SD will have 99% of the observations. This is correct. 99%. And mean plus or minus 3 SD will have 99.7%. So that is this thing. So please keep it this, have some idea about this. You will get lots of MCQs with regards to this. And one thing I have forgotten to mention is, in a normal distribution, it's a bell shaped, mean, median, mode, everything at the center, and this will go to plus infinity, this will go to minus infinity. Plus infinity and minus. ධන පැත්තෙන් යනවා ධන අනන්තයට, ඍණ පැත්තෙන් යනවා ඍණ අනන්තයට. මේක තමයි normal distribution එකේ අනිත් properties එක. මොකද මේක ඇරෙයි දෙකිනුත් MCQs ගත්තා. කවුරු හරි අහලා දෙනවා memorize කරන්න ඕනේ කියලා. memorize කරන්න ඕනේ නැහැ. පොඩි idea එකක් තියාගන්න. Of course you need to remember this. මේක පොඩි නිකන් රටාවකට මතක තියාගන්න පුළුවන්. ඒ කියන්නේ අදහස තමයි 2SD තමයි 95.5 වෙන්නේ. 1.96 SD තමයි 95%. Okay, and you can see some of the videos in the chat box. And how many, now next question is, how many normal distributions that we can have? Even though we say that it's normal distribution, what we discussed was standard normal distribution. Standard normal distribution is the distribution that we discussed, where we have all these means at the center and 1 SD, 2 SD, so like that. But normal distributions, we can have infinite number of normal distributions. For example, අනන්ත සංඛ්‍යාවක් normal distributions එන්න පුළුවන්. Right? ඒ කියන්නේ අපිට මේ bell shape curve එකක් වෙන්න පුළුවන්. පොඩ්ඩක් මෙහෙම වෙන්න පුළුවන්. මෙහෙම වෙන්න පුළුවන්. All those are normal distributions. We can have infinite number of අනන්ත සංඛ්‍යාවක් තියෙන්න පුළුවන් normal distributions. හැබැයි අපි මේ කතා කරේ standard normal distribution එකේ properties. I hope that is clear. Okay, the next one is if a distribution skewed to left or negatively skewed, or if a distribution skewed to right or positively skewed, positive, in some MCQs they just mention that it's right, and negative they mention that it's only left. Right? What is the best measure of central tendency in this kind of distribution? What is the best measure of central tendency in this kind of distribution? The thing is, it's like this. Normal distribution එක නම් මොකක් වුණත් කමක් නැහැ. Normal distribution එක generally mean, median, mode ඔක්කොම මැද තියෙනවා. Normal distribution, everything is at the center. Right? And but in a skewed distribution, generally it will be like this. Mean, median, you should know that mode is at the top because it's highest frequency, mode. And in the other side also, the mode will be at the top because it's the highest frequency. Then median, then mean. Mean is towards the tail, and here also the mean is towards the tail. Right? So now somebody please tell me what is the best measure of central tendency in a skewed distribution? Best measure of central tendency in a skewed distribution. The answer is median. The reason is, yes, exactly. Chatu Hansini, thank you. And its the answer is median. The answer is median. The reason is, despite the shape of the original distribution, median will be at the center. Median will be at the center. Right? Median will be at the center. Right? Mean, and the other thing is, mean is affected by the outliers. Here also mean is affected by the outliers. We might be thinking about the harvest of a coconut land. Assume that we have 5 trees. First one gives 5 coconuts. The second one gives 7 coconuts. Next one also 6 coconuts. The next one 8 coconuts. The last one might give 100 coconuts. Then the average will be around 20s, which is not true. But the median is you need to arrange this in ascending order, and then you have to get the central value. The central value here is it's 7. Right? In the skewed distribution, the best measure of central tendency is median. Okay. Now we have one issue. Assume that now in one school there are 3 classes. There are 3 classes. This is class A. This is class A, and this is class B, and this one is class C. All are standard, not standard, no, but all ABC are normal distributions. මේ තුනම normal distributions. එතකොට මේ තුනේ average දක්වන හිතන්නකෝ. right 88 88යි. එතකොට දැන් මේ ටීචර්ස් අසුන්දනා ස්ටාෆ් රූම් එකේදී හම්බ වෙලා අපි කතා කරනවා මගේ ළමයින්ගේ average එක නම් 88යි. ඒක මගේ පන්තියේ ළමයි හොඳයි. Then the class B teacher might tell that so in my class the average is 88. My class is the best one. And class C teacher also will tell the same. Now my average also 88. So which is the best class? That is the question. Which is the best class? Think about 20 seconds. Now, here it's a measure of central tendency. All 3 mean, median, mode, all are same. Yes, all 3 are normal distributions. Mean, median, mode, everything is same. And many answers, I am getting many answers telling that it's B. I don't know. And Roshan says that it's C. Interesting. C. Okay. Now it's interesting. Sayom says it's C. Many supporters are there for A, and supporters are B and C. The answer is I don't know. The thing is now the reason is always the measures of central tendency alone is not enough to describe about the distribution, because here there's a dispersion. We call that as dispersion. Dispersion means dispersion. So in central tendency we know about the central location, only just one point. But dispersion is pathirema. So we need to measure the dispersions as well. Write down the next topic. The next topic is measures of. I'm rushing through all these topics, thinking that you can remember at least some of the theories. Measures of dispersion. Okay, the first measure of dispersion is range. Range is the difference between highest value and lowest value, right? Okay, now in our class the highest mark is 95 and the lowest mark is 65. Because of that our range is from 65 to 95, or our range is 30. That is what is called range. But think about this. Now this is what is called range, right? The next one is now the problem is, assume that now we are comparing 2 classes. High මේ class එකේ ඉන්න අඩි 3ක් කුසෙක් කෙනෙකුයි අඩි 11ක් කුසෙක් කෙනෙකුයි. All others are between 5 to 6 feet. අනිත් class එක තියෙනවා ඒකේ තියෙන්නේ අඩි 5ක් 6ක් අතර තමයි ඔක්කොම උසාවි. This is class A and this is class B. Right? 3 to 11. The second one is 5 to 6. And somebody might tell that the range in class A is 3 to 11 and class B is 5 to 6, indicating that the dispersion is high in class A. But generally, everybody is between 5 to 6 feet. I hope everyone is clear, right? That is the problem that we are having. So the problem with range is also like mean sensitive to outliers. Range is also sensitive to outliers. Right? Okay. Because of that, okay, now the first one is range. The second one is interquartile range. Interquartile range, which you may remember those things, antas chatustaka parase, right? What we do is in interquartile range, what we do is we have a distribution like this and we divide the total distribution in the 100 parts and we exclude the outliers and we get the 25th position and 50th position and 75th position. And interquartile range is IQR. Interquartile range is IQR. IQR is Q3 minus Q1. We get the value in 25th position and value in the 75th position and we get the range. Generally, the range is the highest value and lowest value. But interquartile range is 75th value and 25th value. So the property here is this one is not sensitive to the outliers. Not sensitive to the, it's like median. Median is not sensitive to the outliers. Not sensitive to the outliers, right? I hope interquartile range is also clear. And another thing I need to highlight, the first one is range, second one is interquartile range. So the best central tendency, dispersion. So best in a skewed distribution, best measure of central tendency is median, and here it's interquartile range. If you read research papers and all, you will see median and within brackets interquartile range if you are talking about a skewed distribution. Skewed distribution. That means if you are dealing with discrete variables in a research, we have to go with medians and IQR. If we are doing with height, weight, like that, continuous variables, we can interpret the data with means and standard deviations. Okay, that's all. Now, okay, the thing is, in a, okay, again a question now. Last, yeah. Thing is, in the best measure of central tendency is in a skewed distribution is median. Best measure of dispersion in a skewed distribution is interquartile range. Skewed means most probably the distribution might be a discrete. එතකොට අපි රිසර්ච් එකකදී discrete values එක ඩීල් කරනවා නම් අපි median and interquartile range එක interpret කරන එක හොඳයි රිසර්ච් එක data. So that's it. Okay. Now the first one is range, the second one is interquartile range. Both the problem is අපි හිතනවා මේ හොඳම ළමයි නරක ළමයි නැත්නම් 25th ළමයි 75th ළමයි. We are describing the total distribution. We are describing the total distribution by using only two individuals. දෙන්නෙක් පාවිච්චි කරලා තමයි මුළු ඔක්කොම ගැන කතා කරන්නේ. මේ දෙන්න මෙහෙම හින්දා ඔක්කොම මෙහෙම නැතුව. Which is not good. Because of that, they have introduced a new concept called variance. Right? The next one is variance, where we incorporate everybody to describe about the dispersion. Okay, in a variance, assume that we have 5 individuals A, B, C, and D, and E. These are 5 students A, B, C, D, E. Right? ඒගොල්ලන් විභාගයට ලකුණු ගන්නවා and their marks are these. 5න් 1යි, 5න් 2යි, 5න් 3යි, 5න් 4යි, 5න් 5. These are the marks, right? And the next one is in variance. When you are calculating the variance, this is marks, student, and we have to calculate the x bar. What is x bar? Average. You can add all this. 1 plus 2 plus 3 plus 4 plus 5 divided by 5 is 3. So mean here is 3. And then you have to calculate x minus x bar. Now we are calculating the variance, right? So x minus x bar is 1 minus 3 is minus 2 and minus 1. 3 minus 3 0. 4 minus 3 plus 1. 5 minus 3 plus 2. Okay. Now that is it. Then if you add all together this x minus x bars, the answer will be 0. Again, even though we use the dispersion, which is not good. In this kind of situation, in statistics, what we do is we get the squared value. X minus x bar squared. X minus x bar squared is minus 2 into 2, 4. 1 into 1, 1, 0, 1, 4. Then what we'll do is we get variance equals summation x minus x bar squared divided by n minus 1. The reason for n minus 1 is different. If you are really interested, I don't have time to explain this one. N minus 1. So there's a separate video for n minus 1. You can see in the YouTube channel this n minus 1. I think it's video number around 30 or something. Reason for n minus 1. So you can see that one. Okay. Here summation x minus x bar is the total of this column, which is 10. 10 divided by n minus 1 is 4 equals 2.5. Now we have some value. The variance is 2.5, which gives some idea about that. Mean is 3 and variance is 2.5, right? So this one is 2.5. Okay. The next one is, I'm going to erase this, and I'm going to erase this variance. Again, the first one is range, the second one is interquartile range. Now we are talking about variance. But again, the problem with variance is the square difference. 2.5 gra අපි දැන් ඉස්සෙල්ලා ගත්ත value එක squared one. Square x minus x bar square කරලානේ අපි ගත්තේ square value. Because of that, we need the fourth one, which is standard deviation, that equals the square root of the variance. Right? Standard deviation is nothing but the square root of variance. Generally, we are dealing with standard deviations. If you think about many research papers, this is about standard deviation. Okay, fifth one is, and in this kind of situation now, one might argue that now we are in Anuradhapura, which has the highest dispersion. For example, වැඩිපුරම variability එකක් තියෙන්නේ වැස්සද නැත්නම් රස්නේද වගේ ප්‍රශ්න. වැස්සද රස්නේද? Okay. Rainfall and temperature. Rainfall dispersion might be like this and temperature might be like this. And we can easily tell that the rainfall has highest dispersion in comparison to temperature. But the problem is this is comparative because of the units. Rainfall we measure using millimeters, while temperature we measure centigrades or Fahrenheit, something like that. In order to compare these two, when we need to compare different scales, different units, we can use this fifth concept, which is called coefficient of variation. Coefficient of variation. Coefficient of variation. So we will discuss coefficient of variation. Again, first one is range, second one is interquartile range, third one is variance, fourth one is standard deviation, which is the square root of variance, fifth one is coefficient of variation, where we divide SD divided by mean into 100. That is what is called coefficient of variation. Coefficient of variation. Coefficient of variation. Right? Coefficient of variation. Here you can see now distribution is like this. Mean might be at center, and this is the standard deviation. So if the SD is high, coefficient of variation will be high, right? Because of SD. If it is something like this, distribution is narrow one, SD is low. Its low SD will lead to low coefficient of variation. Low coefficient of variation. Hope that is clear, right? Coefficient of variation, again, that is important for many other things, other places, but for this example, please keep in mind please keep in mind this is very important for comparing the different units when we are talking about dispersion. Okay, the last one is, first one is range, second one is interquartile range, third one is variance, fourth one is standard deviation, fifth one is coefficient of variation, sixth one is standard error of mean. Generally we are talking about standard error of mean, standard error of variance, standard error of different things, right? Standard error of mean equals standard deviation divided by the square root of n. Standard error of mean equals the standard deviation divided by the square root of n, which means this is very important. There are so many MCQs. Statistic is very large, but most of the questions are from this small formula, where SD divided by n root. What do you mean by this? SD divided by n root, that means when you increase the sample size, that means you increase the n. When you increase the n, automatically standard error will go down. And in some of the Jinnan knobs, if you are, so I know that in this participant list there are people who are doing different exams, but according to my experience, the most difficult statistics questions are there in Jinnan knobs paper. Even community medicine is easier than Jinnan knobs. For selection exam, I'm talking about the statistic part, GINNOBS. And another thing is, now there was one question in GINNOBS where they ask about what will happen to SD, when you increase the sample size. Sample size එක වැඩි කරනකොට SD එකට මොකද වෙන්නේ? ඒක අපිට කියන්න sample size එක වැඩි වෙද්දී SD එක ගැන අපිට කතා කරන්න බෑ. නමුත් මේක වෙන්නේ when you increase the sample size, what will happen is the probability of including the outliers. ඒ sample size එක වැඩි කරද්දී මේ distribution එකේ කොටම ළමයා සහ උසම ළමයාව identify කරගන්න අහු වෙන්න තියෙන chance එක වැඩි වෙනවා. Because of that, SD will go up. I think GitHub වලට තියෙනවා නේද? exam දෙකක් තියෙනවා නේ. ඒකේ MCQ pass නම් තව exam එකක් තියෙනවා. In that exam they ask about this part. When you increase the sample size, what will happen to SD? What will happen to SE? SE will go down, but ST will go up. The reason is the probability of including the outliers is high. Right? Okay. That's all about the first session, I suppose. Can I see this? Okay. Okay. I hope you can hear. Okay. The next one is we need to discuss a little bit about data presentation methods. When we summarize using mean, median, mode, and measures of dispersion, then we have to present data. Data presentation. How do we present this data? How do we present this data? Right? Data presentation. Data presentation. The data presentation means the thing is the first one is bar chart. There are about 100 methods of presenting data. Bar chart. Bar chart. In bar chart is something like this. You can remember grade 4 mathematics. We will have bars. This can be either this side also. The thing is, the x-axis will be a qualitative variable because there's a space between these two. There's a space. This may be preference of cars, blue cars, red cars, green cars. So like that. Those are qualitative variables. There's no connection between these two. That is what is called bar chart. The second one is histogram. අපි කියන ස්තම්භ ප්‍රස්ථාරය කියලා. ඒකෙන්ද අපි කොහොමද කරන්නේ? ඒකද in here so generally a continuous variable which will be like this. So 0 to 5, 10, 15, 20, 25. So like this. There's a connection and this represents a range. That is what is called histogram. Histogram in the x-axis will be a continuous scale, whatever the scale is there. Right? And the next one is you can draw a line like this. We call this as a, this is the third one. It's a frequency polygon.
Half an hour.
The fourth one is, so third one is frequency polygon. Fourth one is pie chart.
මුන්ඩිකර ටක් ගාලා කියන්නේ ඇත්ත ඉතින්නවා ඒකට පෙරදිනිය රාගම ළමයි සටසර ගාලා කියන 48 years old abdominal pain අර මේ සටසර ගාලා මෙයා මොනවද කියන්නේ hello right
Hello, sir. We can't hear you, sir.
So we can't hear you.
Can you hear me now? Okay, sorry for this. I think now, yes. Savita, you can hear, right? Okay, we couldn't hear you from pie chart. The reason is now, okay, it was muted. I don't know why. Pie chart, the problem is pie chart again we represent qualitative data. The deficiency of pie chart is we cannot represent 0. Right? We cannot represent 0. Okay. Frequency polygon is just a term. I need to introduce the frequency polygon. The next one was pie chart. Pie chart we cannot represent 0. We are representing qualitative data in pie chart. The next one is box and whisker plot, which we are discussing right now. This is what is called box and whisker plot. Here we have a box and whisker. Maybe box again highest value we could have so it should be Q3 here and Q1 here, and middle we will have Q2. Right, the lowest value will be somewhere here. Make anipatara horizontally තියන්න පුළුවන්. මේ අපි කැමැත්තන එක හදා ගන්න box and whisker plot. Box and whisker plot we use to represent generally the discrete variables because we are dealing with in the quartile range. Q1 is the quartile 1, Q2 is the median, and Q3 is the quartile 3. Where we use it in the quartile range. Right? This is what is called box and whisker plot. This has to be quantitative. This has to be quantitative. It's not only for qualitative. This has to be quantitative. Both qualitative and quantitative data. Qualitative data, what we have to do is we have to take the data in the form of discrete variable, like qualitative variable, this much preferred black, this much preferred green, like that. Then we can plot this kind of data. But again, that will become quantitative. Okay, that is what is called box and whisker plot. Box and whisker plot. There might be some confusions among you because physical participants, there are some of the questions. So you online participants I will try to explain the question and do the answer. But in the moment, that is box and whisker plot. The next one is, I need to mention another thing is the sixth one is stem and leaf plot. Stem and leaf plot is, in the stem and leaf plot, assume that we have something like that 103, 104, 106, 117, 121, 124, like that, 25. We have a stem and we have the leaf. We have the leaf. Stems might be like 10, 11, 12, like that. Now in this series we have 3, 4 and 6, and under 11 we have 17, under 12 we have 121 and 25. We represent data in the form like this. Stem and leaf plot specialty is stem and leaf. For all the other methods we summarize the data, but in a stem and leaf plot we can identify all the values. Stem and leaf plot එක අපි summarize කරන method එකක් උනාට stem and leaf plot එකේ අපේ තියෙන values variables ඔක්කොම මේකේ පෙන්නනවා. Hope that is clear. Okay, that is all about the first session. I have forgotten to do one thing and I will complete that one as well. Initially we discussed about the difference between qualitative and quantitative and discrete and continuous, and another thing is scales of measurements. Scales of measurement. Now we are talking about the distribution. Scales of measurement. There are 4 scales which are nominal scale, ordinal scale, interval scale, ratio scale. There are 4 scales with regards to variables. There are 4 scales, right? Nominal indicates, nominal means name. Nominal क्या है नाम? නමෙන් වෙනස් වෙනවා. ඒ කියන්නේ අපි බලපු preference, colors ඒ වගේ දේවල්. අපි variability එක ඉන්නේ qualitative form එකේ. මේක qualitative. මේ nominal කියන්නේ එහෙම. නමුත් ordinal, when it comes to ordinal, there's a ordinal. CKD stages. CKD stage 1, stage 2, stage 3, stage 4, stage 5. There may be some different classifications in different books. But CKD stage, we definitely know that 2 is severe than 1 and 3 is severe than 2 and more severe form is stage 5. But we cannot tell exactly 2 is 2 times of 1, 3 is 2 times of something like that. There's no proper mathematical numerical difference between these two. Only thing that we know is there's an order, and difference. We know that one is bigger than the other one or smaller than the other one. That's all. And for interval and ratio, those are continuous variables. Continuous variables, only difference is interval is 0 बिंदु කියන්නේ 0 represent a value. For example, temperature. එතකොට celsius බිඳුවයි කියන්නේ celsius බිඳුවයි කියන්නේ බිඳුව නෙමෙයි celsius බිඳුවයි කියන්නේ value එක. හරිනේ? celsius බිඳුවයි කියන්නේ value එක. And ratio කියන්නේ 0 කියන්නේ බිඳුවම තමයි. For example, height, weight, anything. Height එක බිඳුවයි කියන්නේ absence of height. Height එක weight එක බිඳුවයි කියන්නේ absence of weight. You need to know. So that is the end of the first session. We will go ahead with few MCQs that appeared in the past papers. I will discuss quickly. And one of the I have set of MCQs for all, but I did a small pilot study among few participants, and they requested to do the MCQs appeared in past papers. So please see them. Okay, you can see if you go to the MCQ. In a large sample with normal distribution, large indicates it can be normal distribution, right? Mean and mode are the same. The answer is true. Median falls 1 standard deviation. Median falls 1 standard deviation. It's wrong. False. 99%, 7% of the sample. These are originally appeared in some of the papers that were given by the trainees or the doctors. So there are so many problems with these MCQs. Right, 99% of the staff included in USD. This is about this thing. Now you need to remember the values. There's a problem in STEM C. 99.7 indicates mean plus or minus 3ST. Standard deviation is a test of significance. A significant test is a measure of dispersion. I mentioned that it's a measure of dispersion. Next. Here. Give me a second.
ඉංගල රූමෙන් ක්ලීන් பண்ணிடுங்க பிரசாந்தி.
Hope you can see the screen. The second one is standard deviation is calculated from the mean and the number of observations. Standard deviation calculate කරන්නේ අතන mean and number of observations තමයි. මේකේ මම හිතන්නේ මේ ගෙනාපු ස්ටේජ් එකේ ප්‍රශ්නයක් තියෙනවා mean and the number of observations ඉන්නේ අතන කරන්නේ squared mean difference, right? True false is calculated only for a normal distribution. No, wrong. Many people think that standard deviation is calculated only for normal distribution. එහෙම එකක් නෙමෙයි. අර formula එක මම කතා කරා variance එකේ square root එක තමයි standard deviation කියලා කියන්නේ. එතකොට calculated only for normal distribution නේ ඕනම distribution එක standard deviation එකක් තියෙනවා. And standard deviation is same as median. It's wrong. I explained everything. And thank you very much. There are some questions in the chat box. There are questions in the chat box, and the participants themselves are answering the questions. I'm really happy about that. Thank you very much. So you can keep on doing that. Thank you. And next one is measured in unit square. No, measures standard deviation square unit in a variance. Standard deviation එක මනින්නේ a unit එකෙන් the same unit. If you are talking about height in centimeters, the standard deviation comes as in centimeters. Okay, the next one. Okay, the next one is following are qualitative variables. Yes, blood group is a qualitative variable. Hemoglobin expressed as 2 grams per deciliter or less than 2 grams. So that is hemoglobin measured in grams per deciliter is continuous, quantitative. But if hemoglobin is expressed as more than or less than, that will become a dichotomous variable. Dichotomous variable means yes or no, high or low, that is qualitative. So because of that, that is true. Height in centimeters, again quantitative one. Serum cholesterol level, quantitative one. Carcinoma of cervix present or not. Carcinoma of cervix present or not means again dichotomous variable, which is a qualitative variable. So that is true. The next one is best way to present data of association between birth weight and parity. Best way to present data of association between birth weight and parity. Parity P1, P2, P3 of 1,000 mothers assessed by Deviation. Right? There are 1,000 mothers. Birth weight here. Seven A is true. 7A is true. Okay. Best way best way to present data. Okay, now here, unlike many other situations, here we have two variables. Birth weight is there and parity is there. Now we need to present what will happen to parity and pie chart. Pie chart is just a pie chart is now I come to this one. Can you stop sharing this one? Okay. Now in this question, what happens is now we have parity. Now we have parity and birth weight, which is a quantitative variable. Parity is kind of ordinal like variable. Now pie chart, it's difficult to present this one. But what you can do is there's no way that we can measure it as pie chart, right? Second one is box plot. In the box plot, we can do like this. In the box plot, we can measure the P1 like this, P2 and parity 3. Then we can measure the distribution of box plot here. P2 might be like this, P3 might be like this. So we can compare 3, right? So what is the box plot? Third answer. Third answer.
Scatter plot.
That one is scatter plot. Scatter plot, I have forgotten to mention, the scatter plot is something like this. There should be two variables. Scatter plot, if we plot these two association using this one, again we can do that. If it's P1 and P2 and P3, it will be like this. P1, again, this can be used, but it will be like this. P1, the birth rate in the y-axis, it will be like this. And this will be like this. P3 will be like this. We don't know, so it will be like this. It will be 3 lines. Rather than this, box plot is better than scatter plot. The fourth answer is, fourth one is histogram. Histogram I mentioned there should be a scale. Of course, we can plot the birth weight from like 2000 to like 2.1, 2.2, 2.3 like that, 4.5 birth weight. But it's difficult to plot parity, so this answer is out. Next one is dot diagram. Dot diagram is something like that. Again, like there are several dot diagrams. Dot diagram is generally used to express. Dot diagram is used to express the most of the time it's individual values. But here it's a large sample. Because of that, that answer also out. Because of that, the answer is box and whisker plot. If this question true and false, the correct answers are box plot and scatter plot. True and false. The question is if, can you share it? The question is, if the question is about if the question is true and false type, what will be the answer? Scatter plot
B and C.
box plot are true. Dot diagrams also we can present, but
Yeah.
as they mentioned that 1000 mothers, because of that, dot diagram is also false. But if I make this question, I will not go with the similar answers. Okay, the next question. Okay, so that's all about part 1. So we go to the part 2 of the session, and after that, answers for 7. Again, people are asking, so somebody else can answer because I explained those things. Okay.
Answers for 7 are true, true, false, false, true.
Sorry, I had a net problem. I mean
Okay, the
the
next
test
one is
space box plot, right?
okay. Next one is generally now in
Yes, it is
clean
box plot.
mind. Please go to in clean mind. Please go to the next session. Generally, there are populations. Generally, there are populations. Okay, the next one is we have populations to study. Population is something like this. We have populations, but we cannot study each and every one of the population. Because of that, there are so many samples that we cannot take. We can take random and representative samples and study about the sample. Within the sample, there are individuals which we call units. So population is there, sample is there, and unit is there. That is what is called this. But in the sample has to be random and representative. Random and representative. That means it should be a random sample of the population and it should be representative. It should be a right population. That means all the people in the population should be included in this sample. Right? In order to take this kind of sample, we have to take samples. We have to take samples. Right? The next topic that we are going to discuss is sampling. The topic is sampling. There are situations we may not need random sample, right? We just need the sample. In that case, we can go for non-probability sampling technique. Non-probability sampling technique. And if you need a random and representative sample, we have to go for probability sampling technique. Right? What are the non-probability sampling techniques? First, we will discuss little bit about non-probability sampling techniques. First one is non-probability. Here, there's a population. We need a sample. Sample may be not in this shape. It may be different shape. We don't need this one. That is because of somebody might ask the question like that. Why do we take? It's depend on the objective of the research. Right? We might need or the situation. For example, we might need to study about the commercial sex workers. Commercial sex workers, as we do not have the list or something like that, right? So we cannot take a random sample. In that case, we need to go for some we need to go for non-probability sample. Or maybe we need to study about the satisfaction of the patients coming to OP. It's better to go for a random sample, but if the research is just to have some idea, then a convenient sample may be enough. So there are several techniques like convenient. One is convenient sample. I'm not sure about the spellings. Convenient sampling. Convenient sample is the convenient sample. That means you go and take whoever the convenient people for your sample, right? That will not representative and random sample, but for the purpose it may be enough. So that is what is called convenient sample. Or else you can go for consecutive sampling. Consecutive sampling. Consecutive sampling means you take the first one and second one. For example, the things like you are doing a study on dengue patients. You recruit the first dengue patient, and second one may be admitted. The next day, you take that person and consecutive sample. Let go with consecutive sample. The third one is quota sampling. There are hundreds of methods for non-probability sampling technique. Quota is we give a quota. It's like අපේ ඉන්ධන quota මේ පහුගිය කාලෙදිත් මේ අයට මෙච්චර quota එකක් දෙනවා. ඒ වගේ අපි කියනවා මේ අයගෙන් මෙච්චරයි මේ අයගෙන් මෙච්චරයි. ඒ වගේ quota එකක් දෙනවා. Quota sampling. You don't need to know much about these sampling techniques. Just but it's important to familiarize these terms because this can appear in MCQs. Then another method is small snowball sampling technique. Snowball. What do you mean by snowball? I hope you can remember in your housemate in your schools, right? In your housemate in your school, right? There are snow games. අපේ ස්කෝල වල housemates වල තිබ්බනේ snow games හිම ක්‍රීඩා. ඒ හිම ක්‍රීඩා කරනකොට අපි දන්නවා මෙතනින් අපි හිම බෝලයක් අල්ලු කරත් පහලට what will happen is ඔය කාටුන් බලලා තියෙනවා නම් කාටුන් බලලා තියෙන හිම බෝලේ මොකද වෙන්නේ? ටික ලොකු වෙනවා. It will be like this. Snowball sampling technique is something like this. If you really need something, a sample, for example, commercial sex workers. You are doing a research about commercial sex workers, but you don't know much. You know few. Amaru if you හොයාගත්තට පස්සේ commercial sex workers maybe A, B, C. අපි මේගොල්ලන්ට කියනවා මේගොල්ලෝ දන්නේ හින්දා මේගොල්ලෝ දන්න තව අයට කියන්නේ. අපි ඒක රෙක්රුට් කරනවා ටික ලොකු වෙනවා. ඉතින් ඒගොල්ලෝ දන්න අයට කියන්නේ. So like that you increase the sample. It should not be random and representative, but you are taking the sample. Those are about non-probability sampling. Non-probability sampling techniques are not random, neither representative. And the next most important thing is we need to discuss about probability sampling technique. Probability sampling technique. Probability means it should be random and representative. First one is simple random sampling. Simple random sampling generally for small samples, small populations. Small populations where you know the list of the individuals in the population. ඉස්කෝලේ ළමයි 1000ක් ඉන්නවනම් අපි දන්නවා ඉස්කෝලේ list එක තියෙනවා. Then you take each and everyone in the population. There may be 1000. These small populations we call finite populations. These are not infinite. Finite populations, 1000. In 1000 we api lottery method එකක් හරි නැත්නම් random number generation හරි random number tables හරි මොනවා හරි පාවිච්චි කරලා we take, if our sample size is 100, we take 100 from this 1000. It's random. The first one may be 29, the second one may be 1, the third one may be 900, like that, fully random. In simple random sampling, the main property is each and everyone in the population will have equal chance to be included in the sample. Each and everyone has equal chance. Each and everyone has equal chance in simple random sample. Right? Simple random sample. That is it. That is simple. That is about simple random sampling. First one is simple random sampling. The second one is stratified random sampling. Stratified random sampling. Another thing is stratified random are for heterogeneous populations. Heterogeneous populations means the population is not same, right? We need now simple random sample homogeneous. කොතනින් කොහොම ගත්තත් එකයි. හැබැයි stratified random population එකේ ඉන්නවා Sinhalese, Tamils and Muslims. We might be study about some kind of socio-demographic things. Socio-demographic things are different from community to community. Because of that, if we take simple random sampling in this population, what will happen is each and everyone will have similar chance. But we might need higher amount in the sample from the majority, and the others may need minor, something like that. In that case, we divide the population into strata. So see here in this example, this is Sinhala strata, Muslim strata and Tamil strata. And then we do simple random sampling. We take few from this, few from this, few from this, few from this, right? Few from this. We take individuals from Sinhala, different Sinhala strata, Tamil strata and Muslim strata. That is, first we divide the population into strata. Now important to understand here, now within strata variability is less here. Within strata කියන්නේ like Sinhala එක ඇතුළේ Sinhala අයමනේ. ඒතර ඒගොල්ලෝ අතර ලොකු difference එකක් නැහැ. Within strata variability is less. හැබැයි between strata variability is high. Sinhala completely different from Muslim and it's different from Tamils. Between strata variability is high, within strata variability is less. That is another method of taking probability samples. That is stratified random sampling. The third one is systematic sampling. Systematic sampling also, this can go for the infinite populations as well as finite populations. What we do is we arrange the population in an order and assume that our sample size is 100 and we are doing the research. Okay, we are doing the research in an OPD. OPD එක දවසට ලෙඩ 600ක් වෙන 600 patients per day and our sample size is 50. What we do is we divide 60 by 50, that will 12, right? And we take the 12th individual, 24th individual, 36th individual, 48th individual, 60th
වෙලාවක් හැබැයි ඒක දැන්
individual.
ගණන් නැහැ. අතට තමයි යවුවේ වෙන්නේ දනා. ඒක හරි.
Okay, so that is what is called systematic sampling. Systematic sampling. Okay. Please mute your microphone. Okay. And the fourth one is cluster sampling. Cluster sampling is technique where for large populations, so that this is Anuradhapura district. In Anuradhapura district, we have different MOH areas. Okay, as there are people from various parts of the country. So this is Sri Lanka. There are several districts. So this district, the districts are different. It's so difficult to study each and every individuals in the district. Now, but we are doing a research about thyroxine level or something like that. Assume that doing the thyroxine, and the clinician assumes that the thyroxine level there should not be much different in these districts, right? So rather than studying all the districts, right? So we can study just one district. අපේ සම්පත් resources ඔක්කොම ඉතුරු කරගන්න අපි කරන්නේ මොකද්ද? අපි එක district එකක් study කරනවා. Just one district. And we may not study all the districts because that is enough. That is adequate. That is the reason. right? That is the reason, right? That is the reason. And cluster sample, we call these are clusters. Cluster 1, cluster 2, cluster 2, 3, cluster 4, cluster 5, like that. And we take just one cluster and study all the individuals. That is what is called cluster sampling. But you know that even studying all the individuals in one cluster is also difficult. Because of that, the fifth sampling technique, that is multi-stage sampling. Multi-stage sampling, use the population, you select one cluster or maybe two clusters, and within that cluster there may be few, you may be selecting few clusters, very small clusters, and from that you may be selecting individuals using different sampling method, maybe simple random sampling here. What if PHM area and at the gram area? Simple random sampling. So that is what's called multi-stage sampling. But by definition, by definition, cluster sampling is taking one cluster and study everybody, right? But we can go for two-stage cluster if that is big one, or three-stage cluster, of not multi-stage cluster. But the important is this cluster we will select randomly, assuming that between cluster variability, we think that all the clusters are same. But in stratified random sampling, between strata, Sinhala are different, Sinhala and Tamil are different. But here, between cluster variability is less because we assume that all are same, right? And but within cluster variability is high. Within cluster variability is high because this cluster might include Sinhala, Muslim, Tamil, everybody. Right? Okay, so we can generalize. So all these are probability sampling technique where we take random and representative sample. But my question is, which is the most unbiased sampling technique? Most unbiased sampling technique? Most unbiased sampling technique? Most unbiased sampling technique is simple random sampling, because simple random sampling, each and every individual has equal chance. But that doesn't mean that will get the total representative sample because of the heterogeneity of the population. Population like Sinhala, Devala, Muslim, different country in. Okay, so that's all about sampling technique. We discuss about probability and non-probability sampling techniques. We'll move on to the next MCQ session. Before that, I need to see this schedule. Okay, this one following. प्रश्न को there are questions, I will answer those things. Simple random sampling. Simple random sampling, as I mentioned you earlier, simple random sampling is the most unbiased sampling technique. Less suitable than cluster sampling in large field study. Yes, cluster sampling is more suited for, as I mentioned, large field study, while simple random sampling is for small populations. That means small population means that means finite populations where we don't that list. I mentioned that there is something list. List means the sampling frame. අපි ළඟ අපි ශ්‍රී ලංකාවේ population එක ගැන කරනවා නම් ශ්‍රී ලංකාවේ population එක තමයි sampling frame. අපි කරනවා knowledge attitude practice of student doctors in this hospital. එතකොට අපි sampling frame එක වෙන්නේ මේ hospital එකේ doctors. අපි එකෙන් random sample එකක් කරනවා සර්. එතකොට ඒක තමයි අපි කියන්නේ sampling frame එක. එතකොට අපි generally sampling frame කියන එක අපිට define කරන්න පුළුවන්. නමුත් අපි simple random sampling වගේ sampling frame එකේ list එකම අපි ළඟ තියෙනවා. එතකොට less suitable than cluster sampling for large field study, that is true. Meet sampling frame. Yes, sampling frame එක කියන්නේ මේ list එක all individuals should be able to name. So if we have the name, we can easily do the lottery method, random number generation or anything, because of that is what is called we need sampling frame for simple random sampling. Also, we need sampling frame for stratified random sampling. But for cluster sampling and multi-stage sampling, we are not talking about the list of individuals, or we are not talking about sampling frame. The other thing is systematic sampling. Systematic sampling, more importantly, systematic sampling, it can go in both ways. We might have the sampling frame, we may not have sampling frame. For example, අපි කරන්නේ මහවැලි ගඟේ water samples කරනවා. ඒතර මහවැලි ගඟ කියන්නේ infinite population එකක්. එතකොට අපිට කොත්මලේ නෙමෙයි සිරිපාද ගන්ධ ඉඳන් ත්‍රිකුණාමලයට සෑහෙන දුරක් තියෙනවා. අපි ඔක තෝර ගන්නවා හැම මීටර් 100ටම sample එකක් ගන්න. එතකොට අපිට මුළු distance එක දෙකට බෙදලා එහෙම කරන්න අමාරුයි. හැබැයි අපි කරන්නේ systematic sampling එක අපේ sampling frame එකක් නේ. ඒ වගේ අපි කරන්න පුළුවන්. අපි කැලේක ගස් ගැන කරනවා. කැලේක ගස් ගැන කරනකොට අපිට ඒක ඒරියා එකක් අරන් ගන්නට වැඩි අපිට පුළුවන් කැලේ මැද්දේ එක පාරක් අදින්න. පාරක් අදලා මේ පාරේ මීටර් 100ට හම් වෙන ගස් ගැන අපි ස්ටඩි කරනවා. ඒ වගේ දේවල් කරන්න පුළුවන්. ඒක systematic sampling where we don't know the sampling frame. අපි OPD එකේ කරනවා. අපි දන්නවා 600ක් එනවා කියලා. ඒ වගේ වෙලාවට systematic sampling we know the sampling frame. Okay, in sampling, question number 24, in sampling, in cluster sampling, sample can be produced without the sampling frame. Yes, cluster sampling also අපි sampling frame එක නැතුව අපි හදන්න පුළුවන්. In simple random sampling, everybody in the population has an equal chance to get into the sample. Yes, that is not for all the probability sampling techniques. That is only for simple random sampling. In simple random sampling, can't take subjects outside from the frame. True. අපි සාමාන්‍යයෙන් ගන්නේ question 6 for the answers. I hope that you know. The first one is less suitable than cluster sampling. True. Need sampling frame. True. All cases and equal chance being selected. True. True. In second one, A, cluster sampling without sampling frame. True. B, true. C, true. D, systematic sample production is easier than simple random sampling. The answer is I don't know. It depends. මේ ටික පරණ question 2016 වුණාට මේක දැන් ඒක හරි bias ප්‍රශ්නයක්. Simple random sampling and systematic sampling අපිට ඒක it depends on the situation. හැබැයි simple random sampling අපි generally small populations වලට apply කරන හින්දා අපිට generally කියන්න පුළුවන් simple random sampling easy කියලා. ඇයි අපි random list එක තියෙන අපි ගන්නවා. හැබැයි අපි ගන්නේ OPD එකේ උදේ ඉඳන් හවස වෙනකන් ඉන්න ලෙඩ උනා. අපිට පුළුවන් අපි උදේට එන්න ඕනේ. අපෝ සමහර අපිට පළවෙනි ලෙඩ වෙනවා. ඊළඟ ලෙඩ 9 හමාරට වෙනවා. ඊළඟ ලෙඩ 9 30 වෙනවා. simple random sampling හරි මේකක් ඔය systematic sampling ගත්තොත් අපි පැයෙන් පැයට නම් ලෙඩ ගන්නකොට අපි පැයෙන් පැයට. ඒක systematic sampling lazy. ඒක totally ඒක depends on the situation. ඒකට මම හිතන්නේ මේ ප්‍රශ්න හොඳ එකක් කියලා. මේක දැන් modern ප්‍රශ්න වලදී ඒක අහන එකක් නැහැ. SD will reduce if the number of subjects are increased. I don't know මේක මෙතනට ආවේ ඒක කියලා මම දන්නේ. But anyway මම මේ number of subjects වැඩි වෙනකොට SD එක නෙමෙයි අඩු වෙන්නේ SE එක. ස්ටෑන්ඩඩ් එරර් තමයි අඩු වෙන්නේ. SD එක නෙමෙයි අඩු වෙන්නේ. හැබැයි SD එක වැඩි වෙන්න පුළුවන් කිව්වා මම ඉස්සෙල්ලා හේතුව තමයි because of the probability of including the outliers. Okay. ඒක එතකොට false. D කියන එක it's I don't know. Simple random sampling and cluster sampling. Design effect is more in simple random sampling. Answer is false. I'll explain that one. Sampling frame is needed. Sampling frame is needed for simple random sampling, but not for cluster sampling. Design effect එක කියලා කියන්නේ අර මම කිව්වේ design effect කියලා කියන්නේ අපි දැන් simple random sampling නම් each and everyone has equal chance. එතකොට හොඳම random and representative sample එකක් එන්න chance එක තියෙනවා. හැබැයි cluster sample වලට යනකොට cluster sampling වලට යනකොට when we are talking about the cluster sampling we assume that all clusters are same. Because of that we introduce small error in cluster sampling in comparison to the simple random sampling, right? In order to remove that error we increase the sample little bit in cluster sampling. We increase the sample little bit by introducing this thing called design effect. Design effect එන්නේ cluster sampling එක කතා කරන්නේ. Design effect එක එන්නේ cluster sampling වල. එහෙනම් design effect එක වැඩිපුරම තියෙන්නේ cluster sampling වල, simple random sampling වල නෙමෙයි. ඒ හේතුව තමයි හැම කෙනාටම cluster sampling වලදී equal chance එකක් නැහැ population වලට. අපි large population වලට deal කරන හින්දා. Okay, next one. Okay, so that's all about MCQs part 2. We will have about 5 minutes break. 5 minutes break, and we will start in about 3 to 5 minutes. Okay, thank you very much. Okay, we will start the second session. Of course, this is third session. We need to discuss so many questions are coming. We discuss according to the time permits. Okay, the next one is I need to discuss a little bit about standard errors. As I mentioned you earlier, can you hear me? Okay, standard error is standard deviation divided by square root of n. And I need to highlight one point here, that is this standard deviation, that is the population standard deviation. You may wonder how population standard deviation, how can it be population standard deviation, because we don't know anything about population standard deviation. But actually what we do is, if we don't know the population standard deviation, we use the standard deviation of adequate size sample. But how it can be, it is a bit longer session. We will share the video in the chat box. You can refer the video and understand why we use population standard deviation but not the sample standard deviation. But actual practice, what we use is representative random adequate size sample size standard deviation for calculation of standard error. Then the thing is this one. Now in the population, if this is the population, what we can do is we can take multiple samples, right? The population, we know that the population mean is mu. Assume that this is population mean. Population mean is mu. Mu is the population mean. And we will have several sample means like this. Sample 1, x bar 1, that is sample mean. Sample 2, x bar 2. Sample 3, x bar 3. Sample 4, x bar 4. So like that, large number of samples, we will have several x bars. X bar 1, x bar 2, x bar 3 until x bar n. Right? then what we can do is we can plot another distribution using these x bars, right? Ideally, if these samples are representative and random, these values should be more or less close to mu. Right? මේවා mu වලට ගොඩාක්ම ලං වෙන්න ඕනේ මේවා representative and random samples. හැබැයි ලං වෙන්න පුළුවන් හරියටම mu වෙන්නත් පුළුවන් නොවෙන්නත් පුළුවන් පොඩ්ඩක් එහා මෙහා වෙන්න පුළුවන්. ඒ හින්දා මේ mu කියන එක මැද තිබ්බොත් එහෙම අපි මේ x bars plot කරොත් ඒවා පොඩ්ඩක් හෝ වැඩියෙන් හෝ අඩුවෙන් තමයි වෙන්න පුළුවන්. හැබැයි mu වලට ගොඩක් ළඟ ඒවා වැඩිපුර තියෙන්න පුළුවන්. අඩුවෙන් ඒවා අඩුපුර තියෙන්න පුළුවන්. So ultimately, this will create another normal distribution. This will create all these sample means will create another normal distribution, which we call this as sampling distribution. Sampling distribution. Or else we call this null curve. You will know what is null curve later, right? And in this normal distribution, again we will have a standard deviation 1, 2, -1, -2. In actual speaking, we know the formula. Standard error is SD divided by n root. So this is the formula. But actually, what happens is this in the sampling distribution, standard error is the standard deviation. So standard error is actually the SD of sampling distribution. SD of sampling distribution, right? And I hope that is clear. In the population, we take multiple number of multiple. So I don't have time to explain everything again and again, but I will try to summarize everything. So now we take multiple samples, and multiple samples, if they are representative and random, these x bars should be more close to the value mu. So if we plot all these x bars, we can plot these x bars either side of mu. This will create another normal distribution. Actually, the standard deviation of this sampling distribution is the standard error. So standard error is actually the standard deviation of sampling distribution. But we calculate standard error using this formula. The formula is standard deviation divided by n root. Hope that is clear. And importantly, okay, this is the sampling distribution where we have mu. Actually, this is what called mu x bar. We will have all these x bars in this sample, right? And we call mean plus or minus 2 standard errors. So we are talking about sampling distribution. sampling distribution, mean plus or minus 2 standard errors equal to again those properties 95.5%. Mean plus or minus 1.96 is will contain 95% of the sample means. Actually 95% of the sample means. Now if we have, now assume that this distribution, the distribution that I have shown in the board is about distribution of sample means of birth weight. අපි එක hospital වල different samples අරගෙන අපි ඒ ළමයින්ගේ birth weight mean බලන එක samples. අපි මේ sample means අරන් plot කරනවා මේ distribution එක. එතකොට මේකට අපි කියනවා sampling distribution of birth weight. දැන් අපි Downs babies ලගේ x bar එක බලනවා. x bar d. දැන් අපිට පුළුවන් මේ x bar d එක, the Downs babies x bar, we can plot this x bar here. And if this x bar is somewhere here, x bar d, it can be different from the other means. It can be different from the other means. If this x bar is somewhere here, it is not significantly different. That is the basis of hypothesis testing. For hypothesis testing, we use this sampling distribution. Right? Only thing is, forget everything. We call this 95% this thing as 95% confidence interval. Right? Only thing you need to know is standard error is the SD of sampling distribution. Right? Sampling distribution. But we calculate this using the given formula, that is SE equals SD divided by N root. Now, some of you are clear, and some of you might have some doubts. We will share these videos in the chat box. You can refer these videos if you need really good understanding. But for the MCQs, I think that is enough. And those who will be sitting for STD exam and community medicine exam, they will have to write essays. And of course, after GINOPS MCQ, then we will have to write essay, right? For essays, I'm covering only the MCQ parts, but those theories are related to those SCQs as well. If we have time, we will do essay discussion separately. Okay, so that's all about this. We will go to MCQ session. Okay, MCQ part 3, that is standard error of mean. Standard error of mean is measure of dispersion. True, yes, it's measure of dispersion. I mentioned that from the beginning. And standard error of mean is the standard deviation of the mean of sample means. Actually, what this is called is sampling distribution. Mean standard deviation, standard error is the standard deviation of the mean distribution. I think there's a problem. Can you hear me?
Yes, sir, we can hear you.
Yes, sir.
Okay.
Yes, sir.
Oh, give me a second. Can others tell me whether you can hear? Okay, thank you.
Yes, sir,
Asus.
we can hear you.
I don't know Asus. Your
Yes,
name.
sir.
Lots of brand names are here. Huawei, Asus. Okay. Okay, standard error of mean is measure of dispersion. True is the standard deviation of sampling distribution or mean distribution. It has to be correct like this. දැන් ගොඩක් අය අහනවා මේක හරියද වැරදිද කියලා. මේක හරියද වැරදිද වුණාට මේ ඔක්කොම තියෙන කට්ටිය ඇත්තටම මේ අරන් ආපු questions ඉඳලා මේ stems වල වැරදි තියෙනවා. හරියට මෙහෙම වෙන්න ඕනේ mean distribution එහෙම නැත්නම් sampling distribution. එහෙම වුණොත් ඒක true. Can be estimated by sample SD. It's wrong. But මේක can be හින්දා can be estimated by sample SD true. හැබැයි can be but ideally it should be the population SD. But what we do is we take representative random live sample and we use that SD. Can be estimated by sample SD true. Less than SD true, but if you remember the protocol, if the sample size is 1, standard error equals standard deviation divided by the square root of n. If the sample size is 1, SD equals SE. But generally we don't do human research using one sample. Right? Because of that, more 99.9% of the time it's less than SD true. Standard error of mean is descriptive. Actually now the things I discussed up to now, all the things I discussed up to now, data presentation methods, mean, median, mode, range, interquartile range, variance, everything except standard error are known as descriptive statistics. Everything I discussed up to now except standard error are descriptive statistics, and here onwards we are using this standard error for sampling, right? For those are called inferential statistics. Generally standard error is used for inference. ඒ කියන්නේ අපි population ගැන කතා කරද්දී තමයි standard error පාවිච්චි කරන්නේ. ඒ කියන්නේ මෙච්චරලා කතා කරද්දී අපි distribution එකක් කොහොමද බලන්නේ. හැබැයි අර standard error දාලා mean distribution එකක් ඇඳලා ඒ mean distribution එකට අපි තව mean එකක් ගෙනත් දාලා අපි බලන්නේ population එක වෙනස්ද නැද්ද කියලා. ඒ හින්දා මෙතනින් ඉස්සරහට කතා කරන ඔක්කොම අපි inferential statistics කියලා. මේ දක්වා කතා කරපු ඔක්කොම standard error ඇරෙන්න අපි කියනවා descriptive statistics කියලා. එතකොට standard error of mean descriptive නෙමෙයි ඒක inferential. less than SD කියලා කියනවා. less than SD අර මම උඩින් discuss කරපු එක. එතකොට ඒක true. අර sample size එක 1 නොවෙනවා නම් confidence interval divided by 2 or half of the confidence interval. No, confidence interval කියන එක අපි standard normal distribution එකක තමයි අපි මම කිව්වේ ලෝකෙ තියෙන එක standard normal distribution එකයි. හැබැයි normal distribution ගොඩක් තියෙනවා. එතකොට මේ standard normal distribution එකේ confidence interval කියලා කියන්නේ mean plus or minus 2 standard errors roughly. එතකොට ඒක හරි 95% of the confidence 95% confidence interval. හැබැයි confidence intervals තියෙනවා 99%, 90%, 92%. මේ හැම එකටම මේක හරි නැහැ. ඒ හින්දා මේක false. Half of the confidence interval කියන්නේ confidence interval එකෙන් භාගයක් වෙනවා. එතකොට mean plus or minus 2 SE තමයි 95% confidence interval. 95% confidence interval එක mean plus or minus 2 standard errors. එතකොට ඒක දෙකෙන් බෙදුවම මේ අතරම කියනවා නම් ඒත් වැරදි. ඒක උතර හතරෙන් එකක් වෙනවා මේක. ස්ටොප් කරන්න. So this is a normal distribution of sample, means here we have x bar sample and 2SE minus. This total area will be 95% confidence interval. But we have so many other. So making භාගයක් ඇත්තටම 2 standard errors වෙන්නේ. 2SE තමයි මේකෙන් භාගයක්. හැබැයි අපි මේ දෙන 90% තියෙනවා. 85% confidence interval. 99% confidence interval. So different confidence interval. ඒකට ඒවටත් අදාළ වෙන්නේ නැහැ. එතකොට මේක false. mean plus or minus 2 standard errors 95%. එකෙන් භාගයක් කියන්නේ 2 standard errors. confidence interval එකෙන් භාගයක් කියන්නේ වැරදි. mean plus or minus 2 standard errors. 95% confidence interval. So we are having a different discussion with the physical participants. As I am doing a fast review, it's better to refer some of the videos. Of course, for all the questions that appearing in all these pages, the answers are there in the video series. When increases, SD reduced. Standard error වැඩි කරද්දී SD reduce වෙනවා කියන කතාවක් නැහැ. Sample size එක වැඩි කරද්දී SE අඩු වෙනවා. ඒක false. අනික standard error වැඩි කරනවා කියලා concept එකක් නැහැ කොහෙවත්. Better than confidence interval to compare groups. Better than confidence interval to compare groups. නැහැ සාමාන්‍යයෙන් ඒක මතක තියාගන්න අපි confidence මේක ටිකක් පරණ ප්‍රශ්නයක් මේක. අපි manually හදද්දී තමයි මේක වැදගත් වෙන්නේ ගොඩක් වෙලාවට. හැබැයි අපි groups compare කරනකොට අපි confidence interval එකේ අපි කියන plus or minus දෙපැත්ත. confidence interval එක අපි හැම වෙලාවෙම ගන්න mean plus or minus either side. But standard error again just unidirectional එකක්. ඒ හින්දා groups compare කරද්දී අපි confidence interval එක ගන්න පාවිච්චි කරන්නේ standard error එකට වැඩි. Because of that X false. Regarding the confidence interval, 95% confidence interval includes 95% of observed values. After observed values නෙමෙයි තියෙන්නේ 95% of the sample means. 95% confidence interval includes 95% of the sample means, right? Okay. Smaller the sample, larger the confidence interval. Sample එක පොඩි වෙනකොට confidence interval එක large වෙනවා. ඒකම තමයි mean plus or minus whatever the standard errors is the 95% confidence interval. When you reduce the sample size, standard error will go up. Standard error is going up means confidence interval will be wider. I will explain that again. And the next one is confidence interval of a sample can be used to measure statistical difference. That is true when it comes to t-test and all. Confidence. So I don't have much time to explain this. Confidence interval එක පාවිච්චි කරලා තවකලා අපි statistical difference අපි බලනවා. I will explain that part as well. Population mean lies within the confidence interval. That is true. That is true. I will explain this one. Okay, this one now I hope you can see this one. This is the distribution where mu and 2SE is here, minus 2SE is here, right? Assume that this is hemoglobin value of a distribution and of sampling distribution. Average hemoglobin is 10, right? Average hemoglobin is 10. SD is 2, right? What is the SE? SE is 2 divided by, assume that the sample size is 100, right? Square root of 100, right? Square root of 100. So the SE will be 0.2. SE will be 0.2. How do we interpret this? We can interpret this, okay, mean plus or minus 2 standard errors approximately will consist with 95% of the sample means, or else 10 plus or minus 2 into 0.2 will consist with 95% of the sample means. In other words, from අපි samples population එකේ ඉන්න samples ගත්තම samples 100ක් ගත්තොත් 95කම 9.6 to 10.4 අතර තමයි average එක තියෙන්නේ. In other words, මේක අපිට කියන්න පුළුවන් in this interval we are 95% confident that 95% of the sample means are there, because we are talking about sampling distribution. Or else the other thing is we are 95% confident that the population mean should be in this range. Population mean should be in this range. අපි සාමාන්‍යයෙන් අපි sample එකක් ගන්නෙම population එකක් estimate කරන්නනේ. එතකොට අපි කරන්නේ අපි කියන්නේ මෙන්න මේ range එක standard error එක හදලා calculate කරලා අපි කියන මෙන්න මේ range එකේ අපිට 95% confident that the population mean will be there. ඒ හින්දා තමයි අර MCQ එකේ ඒක ඇල්ල හරියට. Population mean is within the confidence interval, it's true. මේ කියන කතන්දරේ පොඩි exceptions තියෙනවා, චූටි misunderstandings තියෙනවා. ඒවා ටික හරියටම clarify කරන අර videos ටිකෙන් ඒ ටික පොඩ්ඩක් confidence interval videos ටික බලන්න. right? ඒක දැනට already share කරලා තියෙනවා. okay. දැන් අපි සාමාන්‍යයෙන් අපි කොහොමද hypothesis test කරන්නේ? hypothesis test කරනකොට අපි සාමාන්‍යයෙන් පළවෙනි step එක okay. අපි simple example එකකින් මේ ඔක්කොම බලමු. අපි hypothesize කරනවා hospital එකක female doctors and male doctors ලා ඉන්නවා. අපි කියනවා IQ එක වැඩි male doctors ලටද female doctors ලටද? IQ එක එච්චරම හොඳ නැහැ. ඒක IQ එක scale එක වැරදි එකක්. average කරගන්න ප්‍රශ්නයක් තියෙනවා. But still anyway, IQ එක වැඩි male doctors ලටද female doctors ලටද? අපිට බලන්න පුළුවන් මෙන්න මෙහෙම. එකක් තමයි generally අපි hypothesis එකක් තියනවා කියලා හිතන්නකෝ. මම නෙමෙයි Dr. We need a doctor. Dr. X hypothesized that female IQ is less than male IQ. මම කියන එකක් නෙමෙයි මේක Dr. X කියන්නේ Dr. X. but අපිට ඒක ටෙස්ට් කරන්න පුළුවන්. ටෙස්ට් කරනකොට අපි පළවෙනි දේ තමයි අපි null hypothesis එකක් form කරගන්න. null hypothesis. What is null hypothesis? null hypothesis කියලා කියන්නේ මේකේ negative form එක. ඒ කියන්නේ females කවුරු හරි ඉතන null hypothesis කියලා කියන්නේ males are less than females. එහෙම නෙමෙයි. මේකේ opposite එක නෙමෙයි. It's not the opposite but the negative form. Females are not less than male. Or females IQ of females is not less than. No, females are not less than males කියන තමයි null hypothesis. null hypothesis එක ඔබ දැනගන්න. ඊට පස්සේ මේ null hypothesis එක ටෙස්ට් කරන්න අපි experiments කරමු. experiment කරලා අපි මෙන්න මේ වගේ distribution එකක් අඳිනවා. that is what is called null distribution. නැත්නම් මේක තමයි අත්‍තරම sampling distribution. දැන් මෙතන sampling distribution එකක් එන විදිහ හිතන්න එපා. නමුත් මේක distribution එක තියෙනවා. මේක දැනගන්න ඕනේ මෙච්චරයි. මේ sampling distribution එකේ අපිට අපි generally 95% මෙන්න මේ විදිහට අපිට range එකක් හදාගන්න පුළුවන්. right? මේ විදිහට අපිට range එකක් හදාගන්න පුළුවන්. if the value is here, so we will name that x. We'll name this as x and the other one as y, right? Now y is a sample mean, this x by is another sample mean. We can call this x by is not significantly different. because it's in the middle, and y bar is significantly different. Y bar is significantly different and x bar is significantly different. එතකොට මේකේ males and females එකේ කොහොමද එන්නේ කියන එක මේ MCQ වෙලාවේ අවශ්‍ය නැහැ. දැන් මතක තියාගන්න. මැදට ආවොත් මොකද වෙන්නේ? Not different. Not different. අගට ආවොත් නැත්නම් y bar වගේ තැනකට ආවොත් significantly different. I will draw this again. So this is the null distribution or sampling distribution, and we have this confidence region, so we call them as rejection region. And if a value is somewhere here, it's not significantly different, and if the value is here, it's significantly different. So what will happen to this now? Y bar is significantly different, and x bar not significantly different. So then what will happen to the null hypothesis? Significantly different means අපි no difference එක cancel වෙනවා. ඒ කියන්නේ null hypothesis reject. We reject the null hypothesis. Not significantly different means we accept the, or we call that as a can't reject, but for the moment take it as accept the null hypothesis. Accept the null hypothesis. That is what you need to do. If there is something, that means no difference. No difference means null value. Null hypothesis. Null hypothesis එක accept කරනවා. If it is in y bar zone, y bar means it's significantly different, where we reject the null hypothesis. And අපි අන්තිම experiment එක finally අපි ගන්නවා p value කියලා එකක්. Because a p value, right? දැන් අපි ගන්නවා මේ තියෙන්නේ 95% region එක. Centrally තියෙන්නේ 95%, right? And එළියේ තියෙන්නේ දෙපැත්තෙම එළියේ තියෙන්නේ 5%. එතකොට 5% වලට අඩු වෙනවා නම් අහු වෙනවා නම් significantly different, 95% හම්බ වෙනවා නම් significantly not different, right? එතකොට 95% කැලේ හම්බ වෙනවා නම් p value එක මොකද වෙන්නේ? p value එක it should be more than, p value is more than 0.05. That means it is not in the 5% region. It is more than 0.05. මේ 5% region එකේ තියෙනවා නම් that means significant region එකේ ඉන්නවා නම් p is less than 0.05. මේ බොහොම simplify කරලා තමයි අපි කිව්වේ. Right? Right. මම මේක ආයෙසරයක් මේක කියන මොකද මේක තමයි concept එක තේරුම් ගන්න ඕනේ එක. මෙහෙම distribution එකක් තියෙනවා. අපි කතා කරන්නේ මැද කොටස ගැන. තව එකක් තියෙනවා අපි කතා කරන්නේ අග ටික ගැන. Here null hypothesis accept करना, here null hypothesis reject करना. And here null hypothesis accept means p value is less than 0.05. We can sorry, p value is more than 0.05. That means more than 0.05 means we not significantly different, and here the p value is less than 0.05. Can you 5% region එකේ තියෙන්නේ? ඒ කියන්නේ අපහසරයක් අපි ගත්තොත් එහෙම මේකෙදි not significant, here significant. Everything should be clear now, right? Okay, now we will go back to Dr. X. Dr. X thinks that now one method of testing is, now it seems that the average IQ value is something like 70. මේ different scale එකක්. මොකද IQ මන්නේ සාමාන්‍ය scale එකට මේ 70. And he hypothesized that female doctors are having less IQ. One method of comparing this is we can compare female IQ mean female IQ mean and we compare against 70, which is a fixed value, right? If there's a significant difference between mean and 70, mean female, we can call that significantly different from 70. May example we compare mean against the fixed value. We compare the mean against the fixed value. So it is again like this. We can compare mean against the fixed value, right? We are using one sample t-test. We have one sample, the other one is fixed value. One sample t-test for this situation. One sample t-test. And the other thing is then we can compare mean females against mean males. ගෑනුවගේ mean එකයි පිරිමියාගේ mean එකයි compare කරන්න පුළුවන්. මෙතන different hypothesis and null hypothesis. For this one we use two sample t-test. Two sample t-test. Right? අපි හිතනවා female like IQ එක අඩු වෙලා තියෙන්නේ මේ doctors උනාට පස්සේ MBBS degree එකට පස්සේ කියලා. ඊට කලින් හොඳ IQ එකක් තිබිලා MBBS degree එකෙන් පස්සේ IQ එක අඩු වෙලා. එතකොට අපි මොකද කරන්න පුළුවන්? අපිට එකක් තමයි අපිට පුළුවන් MBBS degree එක කරන අයගේ mean එකක් බලලා MBBS එක කරපු අයගේ බලන්නත් පුළුවන්. ඒක නැත්නම් අපිට බලන්න පුළුවන් අපි female set එකක් අපි අත්‍තරම ඉන්න medical students females ලගේ බලලා mean free ඒගොල්ලෝ MBBS එක අරගෙන අවුරුදු දෙකක් විතර ගියාට පස්සේ ආයෙ බලනවා. දැන් මොකද වෙලා තියෙන්නේ? එකම group එක අවස්ථා දෙකක්. mean pre and mean post. ඒක අපි ගන්න pregnant mothers hemoglobin, pre-pregnancy hemoglobin and post-pregnancy hemoglobin. නැත්නම් second trimester hemoglobin. We have two means in same sample in two occasions. මේ වෙලාවට අපි කරන test එක තමයි paired t-test. Paired t-test. ඊට පස්සේ අපිට පුළුවන් ඕන මෙන්න මේ විදිහට. අපි ඔය කිව්වට අත්‍තරම මේ ඩිෆරන්ස් එක තියෙන ෆීමේල්ස් ලාගේ නෙමෙයි ෆීමේල්ස් වලට ළමයි හම්බුනාට පස්සේ කියලා කියනවා. එතකොට කෙනෙකුට කම්පෙයාර් කරන්න ඕනේ වෙනවා mean post pregnancy versus mean pre-pregnancy versus mean medical student. तर මේ females ලා බලනවා ළමයි හම්බුන doctors ලගේ ළමයි හම්බෙන්න කලින් doctors ලගේ සහ medical students ලගේ. ඒතර IQ තුනක් තියෙනවා. මේකේදී ඇත්තටම අපි කරන්නේ two or more groups. Two or more වලට අපි පාවිච්චි කරන්නේ ANOVA test එක. ANOVA test එක. මතක තියාගන්න ANOVA test not for more than two නෙමෙයි two or more. In order to compare two or more groups we use the test called ANOVA. ඔය කිව්වට දැන් තව කවුරු හරි කියනවා ආගෙත් කරනවා. ඔය කිව්වට ඇත්තටම ඇසෝසියේෂන් එක තියෙන්නේ වයස යනකොට මිසක් මේ ඔය ළමයි හම්බෙන කතාවත් එක්ක නෙමෙයි. ඒ වෙලාවට අපිට බලන්න පුළුවන් මේ පැත්තට age එක දානවා. මේ පැත්තට IQ එක දානවා. දාලා අපිට plot කරන්න පුළුවන් මොකක් හරි ඇසෝසියේෂන් එකක් තියනවාද කියලා. right? Association එකක් තියෙනවා කියලා බලන්න පුළුවන්. මේකට අපි කියන correlation බලනවා කියලා. මේකට අපි පාවිච්චි කරන ටෙස්ට් එකට අපි කියනවා Pearson correlation. Pearson correlation. එහෙම නැත්නම් අපිට ගන්න පුළුවන් ඔය කිව්වට දැන් මේ අවස්ථා කීපයක් හොඳ. එතන 1 2 3 4 5 එහෙමද? හරි 1 2 3 4 5. And sixth situation is some might argue that ඔහොම නෙමෙයි. ඔහොම කිව්වට හැමෝටම එහෙම නැහැ. females අයගේ තයි කිව්වට ડોක්ටර්ස්ලා ඉන්නවා, males අයගේ තයි කිව්වට ડોක්ටර්ස්ලා ඉන්නවා. ඒක එහෙම නැතුව මේක ඔබ්සර්වේෂන් එකක් නෙමෙයි. ඒ හින්දා අපිට කම්පෙයාර් කරන්න පුළුවන්. 100ට කීයක් female ડોක්ටර්ස්ලා IQ අඩුයිද versus 100ට කීයක් males-ලා ගේ IQ අඩුයිද? Here we are comparing proportions. Here we are comparing the proportions. Proportion of males versus proportion of females. In order to compare proportions, we use chi-square test. Chi-square test. Right? All these things are called for these samples. For t-test and ANOVA, Pearson correlation, except for chi-square, we need to have random assumption because it's a parametric tests. These are parametric tests. This one is different. Chi-square is different one. Parametric test where we have the random assumption. අපිට මේ observations random වෙන්න ඕනේ, normality assumptions මේ distributions normal වෙන්න ඕනේ. එහෙම වුණොත් අපි normal වුණොත් අපි මේ one sample t test, two sample t test, paired t test, ANOVA test, Pearson correlation මේවා පාවිච්චි කරන්න පුළුවන්. හැබැයි normal distribution නැතුව random නැත්තම් skewed distributions නම් අපි පාවිච්චි කරන්න ඕනේ මේවා නෙමෙයි non parametric tests. We call them non-parametric tests. There we compare not the means but the medians. Right? එතකොට අපිට පුළුවන් median against the fixed value compare කරන්න. Median against the fixed value. That means like in parametric we compare mean against the fixed value, one sample t-test. So the non-parametric test for to compare median against a fixed value is sign test. Two sample t-test we compare two means, but in non-parametric we compare the median value, median of one group versus median of other group. For that we use man with the U test. Man with the U test. And paired t-test for pre and post means. So pre and post medians. Pre-median versus post-median. We use Wilcoxon sign rank test. For ANOVA means more than two or more means. So in non-parametric, we compare two or more medians. Group 1, group 2, group 3, two or more medians. For that, we use Kruskal-Wallis test. Kruskal-Wallis test. For Pearson correlation is for to assess the correlation. A non-parametric test is Spearman correlation. Chi-square, of course, is a different one. We are talking about the proportions. So please keep all these things in mind. මේ MCQ එක තමයි මේ දවස්වල ගොඩාක් board of studies touch කරන එක. අන්තිම radiology exam එකේ ගොඩාක් exams වල අර single MCQ එකට ඇවිල්ලා තිබෙන්නේ මේක තමයි. ඒතර මේක touch කරන්න පුළුවන්, මේක අහන්න පුළුවන් එකම ප්‍රශ්න. Parametric statistics are. එහෙම නැත්නම් non parametric statistics are කියලා දාලා one sample t test, two sample t test, man with new test, Wilcoxon sign rank test වගේ එකක් එන්න පුළුවන්. ඒකට අමුතු නමක් තියෙන මොනවා හරි තිබ්බොත් ඒක ගොඩක් වෙලාවට නම් පැරාමීටර්. කට්ටිය ඉන්නව නේද? ගොඩක් වෙලාවට chat box එකට MCQ එකක් ආවේ නේද? Okay. Okay, I hope that is clear, right? Okay, thank you. And okay, okay, Smith. Okay, thank you. And I hope that is clear. These are about tests. One thing that I need to highlight is about Pearson correlation. Right? Pearson correlation I need to discuss a little bit because that is one of the famous area of asking questions. That is about Pearson correlation. I'm going to clear this one. So your own questions we can discuss after 5. Because everybody will not have questions. Those who are having questions, please stay after 5 and we can discuss. Okay. It's a different discussion. Different. Okay, the next one is right. Then we need to know. We need to discuss about this correlation coefficient. Correlation coefficient කියලා කියන්නේ අපි we plot one variable in x-axis. It should be quantitative one. Quantitative will height, maybe weight in y-axis. Again, a quantitative variable. Right? And we plot this. And for both x and y-axis should be quantitative. Otherwise, we cannot make up this axis. So this is what is called correlation coefficient. Correlation coefficient. X-axis and y-axis. Right. The thing is x-axis and y-axis, and if the correlation is like this, we call that as a positive correlation. The maximum value we can have is, we call the correlation coefficient as R test. Positive correlation, that is the maximum value is +1. If the R value is more than 0, if it is more than 0, we call it as a positive correlation. If we get something like this, we call it a negative correlation. The minimum R value is -1. Because of that, R ranges from +1 to -1. That is what's called correlation coefficient. Whatever the R value, right? In some books they are mentioning like 0.8 to 1, 0.6 to 0.8, like that. It's very strong correlation. This is strong correlation like that. Rather than that, the most important thing is the associated p-value. R may be something like 0.1, but what about the p-value? If the p is significant, we call it as a significant correlation, right? So this classification, I haven't seen this in the MCQ. Very strong. Even if it is a 0.1, very small weak correlation, if the p-value is significant, we call it as a significant correlation. Generally p-value should be less than 0.05, but 0.05 is something that has to be decided by the researcher, whether you it's 0.05 is adequate or you need to go for. If you are doing a cancer drug experiment, you might need 0.01 significant level. If you are doing a research related to freeze or something, you can go for like 0.1 or 0.2, little bit of higher one, but generally people go with 0.05. That is all about correlation coefficient. One other thing is simple linear regression. Simple linear regression is basic statistical concept where we do the same thing. We have x-axis, we have y-axis, and we have line, and we can plot this kind of graph. If you can remember small h mathematics, y equals mx plus c type, y equals mx plus c type curve. Y equals mx plus c type curves. In simple linear regression, we can identify. So C is we call antakande or intercept. Intercept means make a kohenda kapen. Y axis එක කැපෙන තැන. Where the axis, where the line curve meets the y axis. That is intercept. And M is anukramane, or we call it as a slope. Slope. Right? In here, from simple linear regression, we can identify the change of y with the unit change of x. X එක එකක් වෙනස් කරාම y කොච්චර වෙනස් කරනවද? height එක අඩියකින් වැඩි වෙද්දි බර කොච්චර වැඩි වෙනවද? female length එක අඟලකින් වැඩි වෙද්දි estimated fetal weight එක කොච්චර වැඩි වෙනවද? මේ abdominal circumference එක පොඩ්ඩක් වැඩි වෙද්දි estimated fetal weight එක කොච්චර වෙනස් වෙනවද? That is what is called simple linear regression. Right? Simple linear regression. Correlation coefficient, what we did was whether it's a positive or negative, whether it is strong or weak. Here, what we learn is y is equals mx plus c. We get a quantitative measurement to identify how much y change that we can expect with the unit change of x. That's all about simple linear regression. We can extend this formula to multiple linear regression. This is just multiple linear regression where we have y equals m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus c, like that. So in the best example is our fetal scan. Fetal scans, we measure abdominal circumference, femur length, head circumference, so like that. By using everything, we identify the estimated fetal weight. So multiple linear regression is there in ultrasound scanning pregnancy. That's all. That's a simple additional thing. Okay, we go to the MCQs. No, wait. We have one more. That is errors. Errors means this thing now. I hope you can hear. Okay. In the distribution, this is the significant region. This is what is called significant region. And we have x here. X. So x p value is 0.04 means significantly different. And we have y. Y p value equals 0.06. Not significant. Not significant. Right? P value is 0.06, which is not significant. Right? Hadai means statistical significance enne hari non-statistical significance එකක් එන්නේ hari වැරද්දකින්. X is significantly different but which is wrong. Y is significantly not different but actually it should be significantly different. That means we are making an error. We are making an error. So X should be actually not significant, but test came as significant. We call this error as, we are recognizing significant it is not significant, but we recognize this as significant, which we call type 1 error. Type 1 error. Why? We got it as not significant, but it should be actually significant. It should be actually significant. We call this as type 2 error. Type 2 error. Y should be go somewhere here, X should go somewhere here. If I summarize everything here, so error, result, actual, error, type 1 error or type 2 error. Result is significant or in type 1 error is significant or null hypothesis rejected. Null hypothesis rejected. Error significant. Null hypothesis rejected. But actually it should be false negatives, false positives. I can come here. But actually it should be not significant and null hypothesis should be accepted. අපි සාමාන්‍ය null hypothesis accept කියලා කියන්නේ නැහැ. ඒක different explanation. Here in type 2 error the result is not significant and null hypothesis accepted, but actually it should be significant and null hypothesis should be rejected. The next item is how we can correct it. In order to correct it, type 2 error, how we can correct it? For type 2 error, we can increase the sample size. When you are increasing the sample size, this kind of distribution will take like this. So type 2 error will be less. When you increase the sample size, we can minimize the type 2 error, while for type 1 error, we cannot change this with increasing the sample size. We have to adjust the level, P level. That means whether it's 0.05, we can shift this to towards 0. The previous cutoff is 0.05. We may change this to 0.01, but we don't use this term. We have to adjust our significant level. So adjust P level. Yeah, adjust the P value or cutoff predesign cutoff value. That is how you overcome type 1 error. Type 2 error, you have to increase the sample size. So that's all about the errors. And one asked about false positives and all. That is again, I have seen in several places people are using this false positives and false negatives. Even the MCQs there are things. Now, first of all, you need to determine now what do you mean by positive. Positive means significant. You need to know this one, right? Significantly different or significant, right? Significant. If it is significant, we call that as positive. Now this can happen. Now we can interpret this one. Significant means here we have actual, positive, negative. Actual, here test, positive, negative. We are talking about statistical test, not screening, right? It is significant. Positive means significant. Here it's significant. Negative means not significant, right? Test positives, that means significant, and actually they are significant, right? Those are we call two true positives. Test positives, but actually they are negatives, right? So it's false positives. False positives. The test is negative, but actually they are positives. We call them as false negatives. Test is negative. Test is negatives. Here we are not talking about T, SH, F, fast in blood sugar or something like that. We are talking about T test, R test, those things. False negatives, and these are true negatives. Actual negative, these things. The thing is now, what do you mean by false positives? Actually, the test is positive or significant. So the p-value is less than 0.05, which is wrong. That means type 1 error. And false negative means this one false positive. Test take a positive, but actually negative. And false is the positive. Huh? If somebody feels that the false negatives and false positives should be changed, no, it's not, it's correct. Right. Again, that I'll explain this again. Now, false positives means positive. I from the beginning I mentioned that positive means significant. Make a base kara. False positives means significantly different. Significantly different. So false positives significantly different. That means p-value is less than 0.05 here, right? Here also p-value is less than, p is less than 0.05. Negative means p is more than 0.05. P is more than 0.05. But what happened is, this is correct, this is wrong, this is wrong, this is correct. I think each and everyone should be clear. Right? False positive and false negatives. But personally, somebody asked about the power of the study. Power of the study, I'll explain. Explain later, right? Okay, so those all about statistical significant test. We have to do some epidemiology part the next time. Until that, we will discuss something related to MCQs. Yes, we go for the MCQs. Okay, so significant test is done. මේ ප්‍රශ්නවල ලොකු කැලි අඩුපාඩු තියෙනවා. Significant test is done. because doctors are biased. That I don't know. ඒක ප්‍රශ්න error එකක් වෙන්න ඕනේ. Patient's information is unreliable. To test the placebo effect, to see whether the result has occurred by chance. This is true. D is true. D is true. නමුත් මේ ABC කියන එක උත්තරේ ගන්න ප්‍රශ්නේ ප්‍රමාණවත් නැහැ. අපිට placebo effect එක test කරන්න we can use significant test. No problem. Patient's information unreliable නැද්ද බලන්න වෙනම test plan කරන්න. නමුත් මේ ABC කියන එක උත්තරයක් ගන්න මේ ප්‍රශ්න ප්‍රමාණවත් නැහැ. ඉතින් D එකට whether the results are occurred by chance ඒක true. To see if there is any difference between the test value and the population value, that is also true. Test value and population value different බලන්න අපි පාවිච්චි කරන්න පුළුවන් significant test. It is also true. ABC is no adequate information about the questions. මේක මම මගේ ප්‍රශ්න දාන්න නැතුව ඕගොල්ලන්ගේ රික්වෙස්ට් එකක් හින්දාම තමයි ඕගොල්ලන්ගේ ප්‍රශ්න විතර දාලා දෙන්නේ. එතකොට මේ කට්ටිය කියන්නේ සැටිස්ෆයි වෙනවා වැඩි තමන්ගේ උත්තර තමන්ගේ පාස් පේපර්ස් පොතේ ප්‍රශ්න වලට උත්තර හම්බුනාම මේ සැටිස්ෆැක්ෂන් එක වැඩි වෙනම ප්‍රශ්න කරනවට වැඩි. ඒකයි මේක දාලා තියෙන්නේ. The study in village A and B about postpartum psychosis revealed in village A 30% and village B 60% women have postpartum psychosis. What test can be used to compare these proportions, right? Here it's about proportions, right? So the student t-test we compare mean, chi-square we compare proportion. Because of that it's true. A student t-test it's false. Correlation and regression, no, it's not to compare proportions. ANOVA to compare two or more means. Proportions can test එකක් නෙමෙයි. So the only correct answer is chi-square test. Right. Somebody asked about ANOVA and MANOVA. I will explain after this one. A study was conducted to find out incidence of cervical carcinoma among Sri Lankan families. A study was conducted to find out the incidence of cervical carcinoma among Sinhalese and Sri Lankan families. Which of the following test significant can be used? Of course, again that is compared to proportions. In order to compare proportions, we have used chi-square test. All the other tests are wrong. Next one is statistics. ANOVA compares one group with several others. Make a cali adu ඇති, but generally you need to know ANOVA compares two or more means. Confidence interval 0.05 to 2 indicates significant difference. This is wrong. The confidence interval, this one, I will explain in the next session. Right? Right? Okay. Chi-square can be used for proportions. It's true. Correlation coefficient lies between -1 to +1. I explained that it's true. Regression analysis, dependent variable on y-axis. Generally, dependent variable is in the y-axis and independent variable is in the x-axis. Independent variable එක තමයි x-axis එකේ තියෙන්නේ සාමාන්‍යයෙන්. Generally y-axis එකේ තියෙන dependent variable. Finish. Next one is about correlation coefficient. Shows strength of the relation between two qualitative variables. No, not qualitative. They should be quantitative variables. So it's false. Shows strength of correlation between qualitative and one quantitative variable. No, again. Qualitative එකක් වුණත් අපිට අමාරු එක plot කරන්න. ඕනෙම නම් අපිට කරන්න පුළුවන් අර මම මුලින්ම explain කරපු parity and birth rate example එක වගේ ඉරි ටිකක් තමයි එන්නේ. ඒ හින්දා එකක් false. Both should be quantitative. ranges from -1 to +1. True. 0 indicates perfect correlation. False. 0 indicates no correlation. Correlation coefficient and regression coefficient show association between two variables. Correlation coefficient and regression coefficient show association between two variables. It's true. I explained the regression and correlation. Correlation coefficient, if 0, indicates perfect strong correlation between two variables. False. Can use for continuous variables. True. We need two continuous variables or at least discrete variables, but they should be quantitative. Values take -1 to +1. True. Can use find out linear correlation between categorical variables. That is important, right? Categorical nemei, that is false. But this linear correlation, that is true, right? I'll explain that. Okay. In correlation and simple linear regression, we estimate only the linear relationships, but not the curvilinear or nonlinear relationships. I will explain that now. The strength and direction of linear correlation, that is sure. The again strength කියලා කියන අපි +1 කොච්චර කිව්වද නැත්නම් -1 කොච්චර කිව්වද කියන එක direction කියලා කියන්නේ plus the minus the කියන. එතකොට ඒක හරි. And it is linear correlation. It's true. Next one. Correlation coefficient varies from +1 to -1. True. R.8 is 2 times of correlation than R.05. That is false. I will explain that as well. It's false, but if the answer is R equals, I'll explain that. 0 is horizontal. Yes, it is. There's no relationship means that the curve or the line should go in the horizontal line. So it's true. 0.8 is 80% related to linear relation. Varadi. I will explain. That is false. I'll explain that as well. Pearson correlation. Maximum value is +1. True. 0 means no correlation. True. Is done by assuming linear association of two variables. Is done by assuming the two variables. It's true. Linear association. It's true. In two variables, units may not be equal. That is not the problem. එකක් height වෙන්න පුළුවන් අනිත් එක weight වෙන්න පුළුවන්, but still we can measure. ඒතර එකම unit එකෙන් assess කරන්න ඕනේ නැහැ. That is true. Next one. Randomized control trial was performed regarding time taken to conceive following two treatments for subfertility. What is the best test to compare effectiveness of the treatment methods? මෙතන බලන්න හොඳට ස්ටඩි කරන්න ඕනේ මේ වගේ ප්‍රශ්නයක් ආවම මොකක්ද කියලා. Randomized control trial එකක් groups දෙකක් තියෙනවා. Time taken to conceive following two treatments. Treatment දෙකක් තියෙනවා. මේකෙදි මේක හරි වැදගත් වෙනවා. මෙන්න මේකේ මෙන්න මේ වගේ data එකක් එනවා. මෙතන ඉවරද sequence. මෙතන ඉවරද sequence. Fine. So this answer D. Answer is D. Answer D should be the survival analysis. It's not Sundial analysis. This is what I received. It should be survival analysis. So the answer is survival analysis. I will explain survival analysis next. Okay, we'll go to the next MCQ. Type 2 error. I mentioned type 2 error and type 1 error. Another names for type 1 error and type 2 error are alpha and beta error. Alpha error means type 1 error. Beta error means type 2 error. So equal to beta error, that is true. More false negative results will occur. Again, මෙන්න මේ ප්‍රශ්නවලට උත්තර දෙන්න තමයි අරක කරුවේ. beta error කියලා කියන්නේ මොකක්ද කියන්නේ significant නැති එකක්. So significant එකක් significant නැහැ කියලා identify කරගත්තා. Significant එකක් significant නැහැ කියලා. ඒ කියන්නේ p value එක more than 0.05. p value is more than 0.05. ඒ කියන්නේ අපි positive කියලා ගන්න significant කියලා ගන්න එක නම් ඇත්තටම අපි negative කියලා අරන් තියෙනවා false negatives. More false negative results is type 2 error. That is true. This means rejecting a null hypothesis when it is actually false. මේ වගේ MCQs හදන්නේ ඇත්තටම මේ concept එකට වැඩිය ඒ ප්‍රශ්න හදපු කෙනා ප්‍රශ්න තේරුම් ගත්ත විදිහට තමයි මේ වගේ ප්‍රශ්න දීලා තියෙන්නේ. ඒ හින්දා අර equal to beta electron type 2 ඒක height no force negative discharge ඒක අර ඉස්සෙල්ලා explain කරලා next one is this means rejecting null hypothesis when it is actually false. That means I mean type 2 error p value is more than 0.05. 0.05 කෙනෙක් වෙනම explain කරන්න ඕනේ. Generally keep in mind that is how we explain p value is more than 0.05, but it is wrong. That means hypothesis is null hypothesis is accepted, right? Null hypothesis is accepted, but it is wrong. So this should be corrected as this means accepting a null hypothesis when it is actually false. So that means this statement is wrong. You should be able to work out this one. So type 2 error means not rejecting or accepting null hypothesis. To answer this, please go and refer the previous session that I discussed for quite long time. Never exceed the significant level. Type 2 error. Never exceed the significant level. This is wrong. I will explain this when I am explaining the power of this type. Type 1 error means falsely rejecting null hypothesis when it is true. So that is okay. Falsely rejecting null hypothesis. That means p value is significant but it is wrong. That is what is called type 1 error. Use false positive results. Yes. False positives means falsely we reject the null hypothesis. False positives. Never exceeds the significant level. Never exceed the significant level. Type 1 error. Type 1 error that is true. That I will explain. Is beta error that is false. This never exceed significant level. I will explain that with the power of the study. Okay, next one. That is true. C is true. I will explain that. Finish. Finish. Stop. I received few questions. I cannot remember them. Of course, I cannot remember them. Some of the things. But anyway, one question is ANOVA and MANOVA. In ANOVA, what we do is we have mean TSH, sorry, mean hemoglobin of group A, mean of hemoglobin of group B, mean hemoglobin of group C. So we compare the different means. That is what is called ANOVA. 2 or more means ANOVA. In MANOVA, what we have is, so we have one value. We are going to compare 3 groups A, B, C. Whether 3 groups are different, whether these 3 groups are different based on their hemoglobin value, TSH value, AST value, here also this value, this value, this value. Based on several parameters. MANOVA is we call multivariate ANOVA. Multivariate ANOVA or multivariable. There are so many. Here only we have just one variable, but 3 groups, that is hemoglobin. We have just one variable. But here we have 3 variables. 3 variables, hemoglobin, TSH, AST. 3 or more. Any other number of variables, we call it a multivariate ANOVA. That is the basically, we compare many groups based on several variables. that is what is called MANOVA. And again type 1 and type 2 error. මේක හොඳටම තේරිච්ච අය සභාවෙන්න type 1 error p less than 0.05, which is wrong. Here p more than 0.05, which is wrong, right? So null hypothesis, everything is okay. We call this as alpha error and this is beta error. Alpha error is p less than now. Here generally the value is here, right? The significant value, assume that this is kept at 0.05, the error is somewhere here, so it never exceeds this one. And actually we can explain this using two, like this, using two graphs, but I don't think that we have this time now. For the moment, keep in mind this one, the alpha error is somewhere within the significant level, which never exceeds, but type 2 error, it's different. Type 2 error is something different. I'll explain that when I am discussing the power, right? So that's all about statistics, and please keep in mind. So toxic. And another question is ANOVA and ANCOVA. ANOVA and ANCOVA. Now get this previous example. We compare A, B, C, 3 groups. Mean hemoglobin, mean B, mean C. This is ANOVA. Another one is ANCOVA or ANOCOVA. ANOVA is analysis of variance. This is an analysis of covariance. In ANOCOVA, what we do is assume that now in these 3 groups, the proportion of males and females might be different. Group B එකේ ඉන්නවා more females. මේකේ males ලා වැඩි, මේකෙත් males ලා වැඩි. Because of that, A is the females ලාගේ menstruation ඔක්කොමත් එක්ක හින්දා hemoglobin value එක අඩු වෙන හින්දා group A එකේ hemoglobin value එක අඩුයි. හැබැයි actually තර්ක කරනවා කවුරු හරි මේ group A එකේ ප්‍රශ්නයක් නෙමෙයි ඒක, it is because of the gender. In ANOCOVA, what we do is we adjust the result for another variable. Here we adjust for gender. මේ gender කියන effect එක අයින් කරලා අපි බලනවා කොහොමද මේක අයින් කරලා අපි බලනවා A B C groups තුනේ වෙනස කොහොමද කියලා. Clear? I think that is clear. Okay. ABC in ANOVA, I hope that is clear. Mean A, mean B, and mean C. And ANOCOVA, I mentioned that somebody might argue that now A, for example, A group එකේ hemoglobin අඩු වෙලා තියෙන්නේ, it's not because of group A, but it's because of the gender composition. ඒ හින්දා අපි result එක adjust කරනවා gender එක. Let's say ANOVA එක ගොඩාක් ANOVA කියන පැයක් විතර ඩිස්කස් කරන්න ඕනේ. But ANOVA එකෙන් අපි කරන්නේ ANOVA එක adjust කරනවා one confounding variable. One confounding variable. I think that's it. Okay. That's all about ROC curve එකත් මම පස්සේ explain කරනවා. Epidemiology part, that is we need to know about something about study designs. Study designs are, there are two types of study designs, which are descriptive studies and analytical studies. Descriptive studies and analytical studies. Descriptive studies and analytical studies. Descriptive studies are there to describe, analytical studies are there to analyze. Api descriptive studies api dannewa thamai case report. Case report එක අපි හැමදාම මොකක් හරි අලුත් case එකක් ආවොත් නැත්නම් අලුත් case එකක special symptom එකක් sign එකක් investigation එකක් මොනවා හරි ආවොත් අපි case report එකක් ලියනවා. ඊළඟ එක case series. Case series is some series of special cases. First few cases of HIV, first few cases of COVID, or any other new symptoms with several cases with new finding. So that is what is called case series. The next one is cross-sectional studies. Cross-sectional studies. Next one is correlational studies. In cross-sectional studies, what we do is we measure the prevalence. We take a cross-section of a population. That means in a village, what is the proportion of people who are having diabetes? Proportion of hypertension in this village? Proportion of diabetic wound among the diabetes population. Like that, we estimate the proportion, prevalence in a cross-sectional study. In a correlational study, I already discussed. It's like in population level data, we plot in X and Y axis, and ultimately we calculate R value. R value. I explain R value whether it's a positive correlation, whether it is negative correlation. That is what is called correlational studies. Then we need to discuss a little bit about analytical studies. So I will in analytical studies, the first one is case control studies. Case control studies. The second one is cohort studies. Third one is experimental studies. Experimental studies. So the idea of using case control and cohort studies are to determine risk factors. Like case controls and cohort studies, most of the time both are to estimate the risk factors. When we are talking about the risk factors, in a risk factor, we have exposure and we have an outcome. In a case control study, we go from outcome to exposure. This is case control. But in cohort studies, we go from exposure to outcome. Again, I will explain the second part. Now we are talking about case control studies. In case control studies, right? In case control studies, from the beginning of the study, we have cases. Okay, patients with lung cancer, patients without lung cancer. We have patients, those are cases and controls. And we go backwards case control studies, we have people with lung cancer, people without lung cancer, and we go backward and we see how many smokers, how many non-smokers. How many smokers in the non-lung cancer group, how many non-smokers. This is the design for case control studies. We go retrospectively and find out how many smokers and how many non-smokers are there. In a case control study, we calculate odds ratio. We calculate odds ratio. How do we calculate odds ratio? That is another thing. So we famous 2 by 2 table. In a 2 by 2 table, we have the outcome here. Okay. Lung cancer plus, lung cancer minus. Here we have the exposure. Exposure means smoking plus, smoking minus. And we have A, B, C, and D. We calculate odds ratio. I'm not going to explain everything. Odds ratio equals, we have to get the cross value. That means AD divided by BC. AD divided by BC. That is AD divided by BC. That is, okay, that is how we get. And how do we interpret odds ratio? Assume that odds ratio is 3. Odds ratio is 3. That means there's 3 times risk of developing. Make a 3 times risk. 3 times risk of developing cancer for smokers compared to non-smokers. I hope everybody is clear. Right? Everybody is clear. අපි හැම වෙලාවෙම odds ratio එක 3 කියලා කියන්නේ 3 times risk කියන එක. හරි නේද? right. මේකේ තියෙන තව කැලලා. අපි දෙනවා මේක 95% confidence interval. Okay. 2 studies found that the odds ratio is 3. මේ study එකේ confidence interval එක 0.5 to 4.5. Examples. මේ study එකේ 95% confidence interval. And in here, the 95% confidence interval is 1.5 to 5. Which one is significant? Which one is significant? Then odds ratio 3 කියන්නේ there's 3 times risk of getting, there's 3 times risk of developing cancer among smokers compared to non-smokers. 95% confidence interval. So now 3 means odds ratio 3 means there's 3 times risk. But what about can't hear it? Okay. Alright. Now I hope you can hear. Others can hear. It seems that there's no technical errors from this. But what about if the odds ratio is 1? If the odds ratio is 1, එකක් නම් මොකක්ද වෙන්නේ? එක ගුණයක risk එකක්. එක ගුණයක risk එකක්. එක ගුණයක risk එකක් කියන්නේ මොකක්ද? Risk is equal. එක ගුණයක risk එකක් කියන්නේ risk is equal. එක ගුණයක risk එකක්. smokers එකයි non smokers එකයි එක ගාන තියෙනවා. ඒක relative value. Odds ratio is 1. Relative distance. Odds ratio is 1. If it is 1, odds ratio is 1 means, odds ratio 1 means, I mentioned you again. So there's a small discussion with the physical participants. There's 1 time risk or risk is equal. Now, if this 95% confidence interval includes the null value 1, if it includes null value 1, the result is not significant. This 95% confidence interval includes 1 because it's from 0.05 to 4.5. It includes 1 Because of that, it's not significant. And here, 95% confidence does not include null value 1. Because of that, this one is significant. So two things should be there. One is the odds ratio has to be high. The other one is the 95% confidence interval should not cross the null value 1. That is clear. I hope that is clear. Okay, that is all about case control studies. We go to the cohort studies.
Odds ratio 1 means no.
One time is cohort. Okay. Now cohort studies. In cohort studies, we are going from exposure to outcome. Exposure to outcome. Exposure to outcome. Here we have groups of smokers and group of non-smokers. And after a follow-up period, we can estimate how many of them will develop lung cancer, how many of them will not develop lung cancer, and no lung cancer. Okay, so that is how we do the cohort studies. At the end, after follow-up period, we measure this. And there's another thing called retrospective cohort studies. We can do retrospective cohort studies if the cohorts were there previously. For example, in teaching hospital Anuradhapura, what will happen? The diabetes incidence among low birth weight and high birth weight. We go back to 1980s labor room records, and we select low birth weight and normal birth weight babies in 1980. But now we are in 2023. Then අපි බලනවා මේ low birth weight එකෙන් කී දෙනෙකුට diabetes හැදුනද? Diabetes නැද්ද? Diabetes හැදුනද? Diabetes නැද්ද? Diabetes හැදුනද? Diabetes නැද්ද? That is how we do. This is what is called retrospective cohort studies. Now we are in 2023, but the cohorts were there in 1980s, and now we assess the outcome. So it's called retrospective cohort studies. Okay. Then in cohort studies, unlike in case controls, in cohort studies we assess relative risk. Okay. In the famous example, lung cancer, no lung cancer, smoking, non-smoking. A, B, C, and D. Relative risk means relative risk equals out of the total smokers, how many of them have developed lung cancer? That is A divided by A plus B divided by out of total non-smokers, how many of them have developed lung cancers? That is what is called relative risk. Relative risk එක calculate කරන්න මෙන්න මෙහෙම. මේකෙදි තාම මතක තියාගන්න ඕනේ තමයි if the relative risk is 3, we interpret relative risk as there's 3 times risk. In the same manner as odds ratio. 3 times risk of developing lung cancer. And the 95% confidence interval also, I am not going to tell it again. If the 95% confidence interval includes null value 1, it's not significant. A 95% confidence interval in null value with an it's not significant. I hope that is also clear. And the difference is the next one is experimental studies. Experimental studies வந்து அப்படி என்ன අපි මෙතන smoking lung cancer අපි මොකද කරන්න යන්නේ අපි බලන් ඉන්නවා. But in experimental studies we call them as interventional studies. There's an intervention. We need to see whether there's a platelet difference after administration of steroids in dengue patients. So in one group, dengue patients, we give steroids, see the outcome. The other group is dengue patients, routine management, outcome. We see what's the difference. We give steroids to one group, we don't give the steroids to other group. There's a human intervention for this one. අපි outcome එක measure කරන්නේ කාපෝ සරයක් mean difference එකක් proportion difference එකක් අපි statistical test එක කතා කරමු ඕන එකක් වෙන්න පුළුවන්. outcome එක බලන්න. එතන interventional studies වල දැනගන්න ඕනේ ඒක තමයි. එතකොට අපි කතා කරන okay, that is the only part that I need to highlight. One thing I need to highlight is here related to the thing is now I need to mention was RCT, randomized controlled trials that we are talking about is included in the experimental study design, RCTs. In the RCT, I hope you may have come across the concept called NNT, number needed to treat. Number needed to treat. This is one of the MCQ, and my roommate who passed medicine in 2016, I explained all these stats to him, but I have forgotten NNT. Just before going to the exam, I explained NNT, and the MCQ was there related to NNT, and he passed. NNT, that is number needed to treat. We have existing treatment. We call that existing treatment A will recover 4 patients out of 100 cancer patients. අපිට දැන් තියෙන cancer treatment එකෙන් අපිට පුළුවන් ලෙඩ 4 දෙනෙක් 100කින් බේර ගන්න ඒ කියන treatment. දැන් අපි දෙන අලුත් එකක් කියනවා අපි. අලුත් එකෙන් අපිට පුළුවන් 8 දෙනෙක්ව බේර ගන්න. 8 out of 100. The question is, what is number needed to treat? What is the number needed to treat? Number needed to treat is actually in order to recover, in order to cure one patient, how many of them has to be treated. So this is like this. Now here we know that the advantage is 4 patients out of 100. Advantage is 4 patients. Here it is now 4 patients comes as like 8 minus 4. 8 minus 4. In order to recover 8 minus 4, that is 4 patients, we need to treat for 100 patients. If so, in order to recover 1 patient, how many of them have to be treated? So this will be 25. 100ක් treat කරනකොට 4 දෙනෙක් බේරනවා කියන්නේ 25කට treat කරද්දී තමයි එකෙනෙක් බේරෙන්නේ. I hope that is clear. Number needed to treat is the concept, and there's another concept called number needed to harm. This is the opposite of number needed to treat that I am not going to discuss right now. Number needed to treat and number needed to harm. Right? In order to recover 1 patient, the number of patients that will be treated. Here that is 25. Please remember that in name ගොඩක් වෙලාවට ඔය දෙකමයි දෙන්නේ. ගොඩක් වෙලාවට මේ exam එකේදී 4කුයි 8කුයි දාලා දුන්නොත් total number එක බෙදන්න ඒ දෙකේ difference. So that is the answer. Okay. Now what difference okay, so that's all about it. The next one is screening.
experimental studies done
Only the mean difference proportion difference only okay, screening. Why do we need screening? Screening is essential when the diagnostic test is now gold standard test. If the gold standard test is expensive, for example, now we have pap smear, but colposcopy is gold standard. If the gold standard is expensive, need specialized training, maybe not widely available, like that. Because of all these reasons, we have to go for screening tests. Now, screening test. Now, idea in the screening is we need to compare screening test versus screening test versus screening test versus gold standard tests. Okay. Now here screening test results. Here we have gold standard test results. Positive, negative. Screening. Sorry. Here we have positive, negative, gold standard test, screening test. A, B, C, D. A, B, C, D. Now there are a few concepts that we need to know. The first one is sensitivity. Sensitivity. What do you mean by sensitivity? Sensitivity is the ability of screening test to identify positives as positives. In simple terms, A divided by A plus C into 100. ඔක්කොම gold standard positive කියන ඔක්කොම ලෙඩුන්ගෙන් කීදෙනෙක් අපි screening test එකෙන් identify කරගත්තද? Next one is specificity, that is the other way around. ඔක්කොම negative අයගෙන් කීදෙනෙක් negative විදිහට අඳුනගත්තද? Or in other words, D divided by B plus D into 100. Specificity, right? Specificity. And one thing to remember is sensitivity and specificity is not affected by the disease prevalence. Disease prevalence එක අපි කොළඹ කරත් අනුරාධපුරේ කරත් වෙන රටක කරත් sensitivity and specificity of screening test ලොකුවට වෙනස් වෙන්නේ නැහැ. හැබැයි positive predictive value and negative predictive value වෙනස් වෙන්න පුළුවන්. The reason is like this. Positive predictive value is out of the total screening positive patients, how many of them actually have the disease? A divided by A plus B into 100. Negative predictive value, that is out of the total screening negatives, how many of them actually negative? D divided by C plus D into 100. Positive predictive value, in other words, it's like this. Ability of screening test. If the screening test is positive, what is the probability of having disease? එතකොට අපි මේ COVID ගොඩාක්ම ගිය කාලේ අපි කොළඹ COVID වැඩි පෙරිෆෙරි වල COVID අඩුයි කියලා හිතුවා. කොළඹදී screening test එකක් දැම්මම positive same screening test positive predictive value high. හැබැයි COVID ඇති ඒරියා එකට ගියාම positive predictive value අඩු වෙනවා. අයියේ population එකේ නැහැ. එහෙනම් මේ positive and negative predictive values කියන එක disease prevalence එකත් එක්ක associate කරනවා. But sensitivity and specificity එහෙම වෙන්නේ නැහැ. Those are the basic concepts about screening. And one asked about ROC curve. ROC curve. Generally, ROC curve. Assume that now, example, alpha beta protein. Alpha beta protein is going up with cirrhosis. Also, hepatoma. You need to differentiate these two. මේ example එක වැරදි නම් sorry. මම වනේ එක example එකක් ගන්නෙ. එතකොට hepatoma and cirrhosis. අපිට මේ alpha beta protein උන බිඳුවේ සිට thousands යනකම් තියෙනවා level එක. කොතනකින්ද අපි හරියටම range එකක් ගහගන්නේ alpha beta protein whether it's positive or negative. අපි ROC curve එක පාවිච්චි කරන්නේ ඇත්තටම මෙන්න මේ විදිහේ cut off එකක් පාවිච්චි කරන්නේ. ROC curve එකත් again මේ sensitivity specificity වලම derivative එකක්. අපි බලනවා අපි කරන්නේ graph එකක 1 minus specificity දානවා. මේ පැත්තට අපි දානවා sensitivity. Sensitivity කියන්නේ again true positives. True positives කියන්නේ ඇත්තටම screening test එකෙන් identify කරගත්ත අය. 1 minus specificity කියන්නේ ඔයගොල්ලෝ නිකන් හිතලා බලන්න මේවා false positives. False positives. 1 minus specificity කියන්නේ false positives. එතකොට one minus specificity කියන්නේ false positives. එතකොට මේකෙදි දැන් ඔයගොල්ලෝ බලන්න අපි ටෙස්ට් එකක දැන් alpha beta protein ඉන්නේ මේක කොහොමද වෙන්නේ? මේකේ graphs කීපයක් එන්න පුළුවන් මෙන්න මේ විදිහට. False positives වැඩි වෙද්දී true positives වත් වැඩි වෙනවා නම් if it is like this it is not good. ROC curve එකේ area under the curve කියලා value එකක් ගන්නවා. Area under the curve is 0.05 තමයි මෙන්න මේ විදිහට කියනවා. මේක not good. හැබැයි අපිට එනවා නම් curve එකක් මෙන්න මේ විදිහට. Right? True positives වැඩි වෙනකොට false positives වැඩි වෙන්නේම නැහැ. හැබැයි ඒක alpha beta protein level එකක් පෙන්නට පස්සේ ඉතින් ඊට පස්සේ යනවානේ ඔන්න ඔය විදිහට. එහෙම නැත්නම් මේක අනිත් පැත්තට. මෙහෙම යනවා නම් ඒ කියන්නේ මේකේ area under the curve එක 1 වෙනවා. මෙහෙම අංශක 90ට යනවා නම් area under the curve එක 1 වෙනවා. මෙන්න මේ වගේ ටෙස්ට් එකක් නම් අපිට පුළුවන් හොඳට differentiate කරගන්න මේ ලෙඩ තියන අයයි නැති අය. ඒතර ROC curve එකේ අදහස තමයි the meaning of ROC curve is whether we can differentiate using these tests. So we can compare alpha beta protein or any other markers. How is the ROC curve? ඒ ROC curve එක හොඳ මෙන්න මේ විදිහට අංශක 90ට ආසන්න එකක් එන එක අපිට තෝරගන්න පුළුවන්. Best test to differentiate the diseased people and non-diseased people. That is what is called ROC curve. Those who needs more things about ROC curves, there are some video lectures in the video series that is under different heading, sensitivity, specificity, so like that. So we will share some of them in the chat box. You can go and listen. Okay, that's all about it. And one other thing that I have seen is causation. If the p-value is less than 0.05, that means statistical significance, but nothing else. Statistical significance, but nothing else. Again, අපිට කියන්න පුළුවන් clinically significant කියන්න බෑ. Statistically significant විතරයි. හැබැයි හැබැයි මේක prove වෙන්න okay, statistical significance. So p value is significant means statistical significance, but nothing else. Another one is asking about likelihood ratios. Okay, I'll explain likelihood ratios as well after this. Okay, the thing is now මේ statistical significance එකක් actually significant වෙන්න නම් තව බොහෝ දේවල් සිද්ධ වෙන්න ඕනේ. අපි බලන්නකො මෙන්න මෙහෙම දෙයක්. අපි බලනවා okay, sour banana, ambul kesel, එක asthma. ambul kesel කෑවම හතිය හැදෙනවා. So that is the example. Sour banana versus asthma. On a statistic p value is less than 0.05. හැබැයි මේක ලෝකෙම එක ස්ටඩි එකක විතරයි කියන්නේ. එහෙම නැහැ. එතකොට එකක් තමයි repeatability. Repeatedly වෙන වෙනම trial research වලින් පෙන්නනවා නම් මේක sour banana is a risk factor කියලා we can accept this statistical significance. We can accept this statistical significance. That is what is called repeatability. Right? Repeatability. අනිත් එක තමයි coherence. coherence කියන traditional belief එකක් තියෙනවා. අපේ ආච්චිගේ 100ගේ කාලේ ඉඳන්ම අපි කියනවා නම් මේ sour banana කියන්නේ හතියට බෙහෙතක් කියලා අපි හිතාගෙන හිටියා නම් කවුරු හරි prove කරනවා නම් sour banana ගේ risk factor එකක් කියලා that may not be. ඒක එහෙම හරියන්න තියෙන අවස්ථාවක්. හැබැයි මුතුන් මිත්තන්ගේ කාලේ ඉඳන්ම අපි හිතනවා මෙන්න මේක මෙහෙම එකක් කියලා. අපි රිසර්ච් එකකින් prove වෙනවා නම් අපි ඒක actually පිළිගන්න තියෙන chance එක වැඩි. තව එකක් තමයි specificity. Specificity කියන්නේ අපිට specifically කියන්න පුළුවන් මේ sour banana හින්දා තමයි. දැන් අපි කෙසෙල් කද්දී අනිවාර්යෙන් කැබුල් කෙසෙල් කරනවා ඉන්නේ කිරිබත් එක්ක. මම මේ examples හරියටම හරියන්න බැරි වෙන්න පුළුවන්. හැබැයි මේ ඇඹුල් කෙසෙල් කන හැම වෙලාවකම කිරිබතත් කනවා. එතකොට කිරිබත් හින්දා තමයි මේක වෙන්නේ. නමුත් ඇඹුල් කෙසෙල් කියලා අපිට දෙකම කියන්න බැරි නම් ඒක specific නෑ. හැබැයි අපිට specifically කියන්න පුළුවන් නම් මේ හින්දා කියලා ඒක හරි. ඊළඟ තමයි strength of association. Strength of association. ඒ කියන්නේ අපි odds ratio එකක් කරනවා 3ක්. තව risk factor එකක් කරනවා odds ratio එක 10ක්. 10 ගුණයක risk එක. එතකොට අපි වැඩිපුරම පිළිගන්න බලනවා odds ratio එක 3ක් ආපු එකට වැඩිය 10ක් ආපු එක. Strength of association. And there are some other things like dose response relationship, and temporal association. Temporal association කියන්නේ හැම වෙලාවෙම cause එකේ ඉන්න ඕනේ outcome එකට කලින්. අපි දැන් අඹුල් කෙසෙල් කන්න පටන් ගත්ත ගිය අවුරුද්දේ ඉඳන් ඇස්මා කියන එක ආදි කාලේ ඉඳන් තියනවා නම් අපිට හිතන්න අමාරුයි මේක තමයි cause එක. ඒ වගේ මෙන්න මේ factors ඔක්කොම එකතු කරලා තමයි අපිට statistical significance එකක් actually significant කියලා කියන්න පුළුවන්. එහෙනම් මෙන්න මේකත් වැදගත්. අපි MCQs වලට ගිහින් තව එකක් තියෙනවා මේ කෙනෙක් අහලා likelihood ratios. මෙන්න මම එකක් explain කරලා ඉන්නවා. Likelihood ratios දෙකක් තියෙනවා. Positive likelihood ratio and negative likelihood ratio. Likelihood ratio. Likelihood ratio කියලා කියන්නේ positive likelihood ratio කියන්නේ sensitivity divided by 1 minus specificity. Negative likelihood ratio කියලා කියන්නේ 1 minus 1 minus sensitivity divided by specificity. Specificity. Okay. Specificity divided by. Sure.
1 minus sensitivity divided by
Keep it up.
specificity.
Okay, that is 1 minus sensitivity divided by specificity. Sensitivity කියන්නේ අපි ගත්තොත් මේක අතරම true positives ලට 1 minus specificity කියන්නේ නැති negative way negative විදිහට identify කරගැනීම හැකියාව තමයි specificity කියන්නේ. 1 minus specificity කියන්නේ negative way positive විදිහට identify කරගත්තා. ඒ කියන්නේ false positives. 1 minus sensitivity කියලා කියන්නේ false negatives, specificity කියන්නේ true negatives. මේක තමයි likelihood ratio කියලා කියන්නේ. ඒ කියන්නේ sensitivity කියලා කියන්නේ the sensitivity is the ability of screen test to identify positives as positives. 1 minus specificity means 1 minus specificity means those are false positives. The screen test is positive but they don't have the actual disease. Those are false positives. Now, by looking at the formula, you can understand that this should be a higher value. If this is high, likelihood, positive likelihood ratio is high, that means true positive is high in comparison to false positive. And here also, if this value is low, negative likelihood value is low, that means we are having high true negatives. Right? So we can use this negative likelihood ratios and positive likelihood ratios also to interpret about the screening test. This can මට හිතන්න මේ likelihood ratio එකක් වගේ මේසරේ MCQ එකට දායි කියලා හිතනවා මට පොඩ්ඩක්. මේකත් බලාගත්තා. Okay, so we go to the MCQs. One asked about why do we need to calculate likelihood ratios. There are several explanations, but main one is if we are talking about sensitivity, we are talking about positives. If we are talking about specificity, we are talking about negatives only. But screening test එකක අපි quality කතා කරන්න ඕනේ positive වීම සහ negative වීම දෙකම එකතු කරලා. එතකොට අපි likelihood ratios වලින් අපිට කියන්න පුළුවන් positives and negative වීම දෙකම එකතු කරලා ඒකට common value එකක් ගන්න පුළුවන්. That is the reason for calculation of likelihood ratios. I would like to know this name of screen. I don't know screens. Okay, experimental study designs involve okay. So now it's almost 5:15. I will not have adequate time to explain most of the other things, but I would like to answer the questions of others. Change everything. Oh, Ash. So we'll discuss some of the other MCQs as well. Okay, experimental study design involves investigating some way to affect the outcome. True. Investigator outcome එකට influence කරනවා. Influence කරනවා කියන්නේ එක group එකකට දෙනවා අනිත් පැත්තට දෙන්නේ නැහැ. True. Investigator introduce some form of treatment. True. Investigator හැම වෙලාවෙම treatment එකක්. That treatment can be either drug or community intervention like breastfeeding එහෙම නැත්නම් hand washing intervention ඒ වගේ ඕනෙම එකක් වෙන්න පුළුවන්. Or quasi experimental studies like the people in health promotion, they are doing lots of things and provide the most convincing evidence for any hypothesis. that is the levels of evidence. I will explain that as well. Stop share. Now this is partly the level of evidence. Okay, generally, okay. Levels of evidence means levels of evidence. There are several levels of evidence, like from level like that. Level 5. Level 5 is expert opinion. These levels are different from country to country. They have different categories, but generally expert opinion. Tamang expert and tamang consultant may field එකේ නම් තමන්ගේ experience එක හරි. හැබැයි expert opinion එකට වැඩි උඩින් තියෙනවා case reports, case series වගේ දේවල්. And better quality evidence we can produce using cross-sectional and correlational studies. And better evidence we can produce using case control studies. And better evidence we can produce using cohort studies. More better studies using experimental studies. So now, when we are talking about the research that we do, right, experimental evidence research gives the best level of evidence. But the only thing is, there's a next level, that is systematic review. Systematic review means where in systematic reviews is a collection of this kind of experimental or cohort or case control studies where we can produce better quality evidence. It's a review, it's not actually a research, but it's a collection of all these articles, systematic review. And better evidence can be produced, that is 1A level, 1A, that is the top level, is systematic review plus meta-analysis. That is the best level of evidence. Unfortunately, several people have asked about meta-analysis. In order to explain meta-analysis, in order to explain meta-analysis, I need separate session. I don't think that we have time to discuss about this interventional studies, clinical trials, and meta-analysis. If you really need, I will try to share a video related to that topic, the errors related to meta-analysis and those things. So these are the levels of evidence. We'll quickly finish the other MCQs. Sure. So if you go to the question in the chat box, they mentioned about during the discussion on, is it psychiatric question? Efficacy of antidepressant, one psychiatrist say that his clinical experience, the new antidepressant A is better than older B. එක psychiatrist කෙනෙක් කියනවා A හොඳයි කියලා B ට වැඩි එයාගේ experience එක දානවා for unipolar depressive disorder. අනිත් එක්කෙනා කියනවා that is another psychiatrist. The consensus of his university department is that antidepressant C is better than either A and B. Describe given reasons how you rate about two statements based on the hierarchy of evidence. I don't know about psychiatry, what is the level? This level of evidence, this evidence ladder is taught in different ways in different things. The thing is now, in hierarchy of evidence, expert opinion, as I mentioned, that is kept at level 5. And the second statement is antidepressant C, that is based on the consensus of different experts. So that is better, right? But I think I'm not sure about the answer, but the expectation of this question, but the answer should be First, both things are at level 5 evidence. So we need more studies to come into a final conclusion regarding the anti-diffusion. However, the second one is based on the consensus of several experts. So that should be in top in comparison to the first one. That should be the answer, but I am not sure exactly their expectation in this kind of essay question. And we'll share that one as well. And okay, I hope you can see the other thing is, so the most convincing, now we are at 15C. 15C provide the most convincing evidence for any hypothesis. Most convincing evidence for any hypothesis. Generally that is true, but keep in mind there are hypotheses which may not be able to prove using interventional studies. For example, we are talking about something existing. Experimental study we need some observational studies. So what are other studies? False because of this any hypothesis part. Studies are always feasible. No, experimental studies are difficult because we need experiment and well control for this. Bias is reduced. That is a partial statement. We need the question should include bias is reduced in comparison to what? Generally, in comparison to cohort studies, case control, and everything, it's better. Bias is less because we control them. That is what is called randomized control. The next one is need a small sample compared to observational studies. And we are also in a power cut. I hope still you can hear. Okay. So we received generator power. Control is good within group. That is a partial statement. Control is good within group. Confounding is less between groups. I'm not sure what they are talking about actually. Generally, both groups should have the similar control and both groups should be matched with the same amount of confounding factors. Right? So because of that, confounding is less between groups. That is a partial statement. Because bias is reduced, control is good, and confounding is less. E, G, and H. I'm not sure about the answers, whether they are correct or not. Next one, cohort study is more expensive than case control study. Sorry, 15F, the answer is true. It's again a problem, it's based on this, but generally, for experimental studies, as we are doing it very well controlled environment, generally we take small number of samples because of the nature of the design. Because of that is true. Cohort study is more expensive than case control. Generally, yes, but there can be case control studies which are more expensive than cohort studies. But generally, cohorts are more expensive because we need a follow-up period. Cohort study is more expensive than retrospective studies. Again, yes, because of the follow-up period, it takes time. Suitable to investigate rare diseases. That is wrong because අපි සාමාන්‍යයෙන් අවුරුදු 20ක් විතර follow up කරාට පස්සේ smokers and non smokers ලා සමහරවිට cancer කට්ටිය එකෙක්වත් දෙක වෙනවා. Smokers and non smokers ලා එකෙක්වත් දෙක වෙනවා. හැබැයි rare disease එකක් තියෙනවා අපිට මේ lung cancer patients ලා 20ක් හොයාගන්න පුළුවන්. එතකොට rare disease investigate කරන්න හොඳම එක case control. හැබැයි case control වලින් තමයි rare diseases බලන්න පුළුවන්. So common disease එකක් තමයි ගොඩක් වෙලාවට cohort වලින් බලන්න පුළුවන්. ඒකේ අද අනිත් difference එක තමයි case control, first we select the patients. In case control studies we can investigate many risk factors. Case control study එක ලෙඩකට බලපාන ගොඩක් risk factors බලන්න පුළුවන්. cohort study එක risk factor මොනවා හරි එක risk factor එකකින් multiple diseases බලන්න පුළුවන්. smoking එක කොච්චර heart attacks එනවද, කොච්චර lung cancer එනවද, කොච්චර වෙන cirrhosis එනවද, ඒ වගේ multiple outcomes බලන්න cohort හොඳයි. multiple risk factors බලන්න case control. Hope that is clear. Exposure is determined at the end of the study. Cohort study එකේ exposure determine කරන්නේ from the beginning of the study, as I mentioned earlier. Birth cohort include births in same year. මේක හරි partial answer එකක්. birth control ඒක අපේ objective එක අනුව different. අපි එක අවුරුද්ද වෙන්නත් පුළුවන්, එක මාසෙ වෙන්නත් පුළුවන්, අවුරුදු කීපයක වෙන්නත් පුළුවන්. මේක තමන්ගේ objective එක අනුව වෙනස් වෙනවා. ඒක partial statement. Multiple effects can be determined. cohort study එක multiple effects බලන්න පුළුවන්. Same risk factor. Starts with diseased people, no, starts with healthy people. හැබැයි මේකත් again මේක starts with diseased people කියන එක focus, but මෙහෙම දෙයක් අපි බලනවා නම් අපි බලනවා diabetes patients ලගේ control එකත් එක්ක peripheral neuropathy එන්න යන කාලය. peripheral neuropathy එන්න යන කාලය. ඒ කියන්නේ diabetes patients peripheral neuropathy කොච්චර කාලයක් යනවද peripheral neuropathy එන්න වගේ. එතකොට ඒ වගේ එකට අපි පටන් ගන්න diabetes patients. අනිත් group එකෙන් diabetes patients. ඒක දෙකේ වෙන disease අය. අපි බලනවා අපි ඒක ඇත්තටම disease එකේ neuropathy. ඒ විදිහට තමයි බලන්නේ. එතකොට මේක generally start with disease people කියන එක focus. මොකද සමහරවල්ලාට disease එකෙන් බලලා පටන් ගන්න disease complication එකක් බලනවා වෙන්නත් පුළුවන්. Somebody asked about BC answers more expensive than retrospective studies. That is true. Suitable for investigate rare diseases, false. See. Next one. Causality and risk factors. I mentioned about causation. The association should be plausible. That is, plausible means the biological plausibility. The example that I discussed, sour banana and asthma. අපිට පුළුවන් නම් sour banana වල තියෙන මෙන්න මේ chemical එකෙන් හින්දා මෙන්න මේ වගේ reaction එකක් දෙනවා, hypersensitivity reaction එකක් දෙනවා. ඒ හින්දා hypersensitivity එකට එනවා අපිට biologically explain mechanism එකක් තියෙනවා නම් මේ risk factor එක අපිට significant කියලා ගන්න පුළුවන්. තව example එකක් අපි ගත්තොත් smoking හින්දා epithelium එක hyperplasia වෙනවා, ඒක metaplasia වෙනවා, ඒක dysplasia වෙනවා, dysplasia වෙලා cancer. එහෙම explain කරන්න පුළුවන් mechanism එකක් තියෙනවා නම් ඒක plausible. එතකොට association should be plausible. That is true. Cause must precede the effect. That is true. That is what I discussed, temporal association. The association between the cause and effect should be strong. Yes. On the strong relationship එකක් තියෙන්න ඕනේ. There should be dose response relationship. Yes. dose එක වැඩි වෙද්දි response එක වැඩි වෙනවා. හැබැයි සමහර වෙලාවට තියෙන එක තැනකින් එහාට dose එක වැඩි කරත් response එක අඩු වෙනවා. dose response relationship එක කියන්නේම මේ cause එකක් effect එකක් බලන්න තියෙන හොඳ එකක්. හැබැයි ඒක වැඩි වෙනකොට වැඩි වෙනවම කියන එකම නෙමෙයි. Removing the factor of interest should reduce the disease. Yes. That is another thing. අපි risk factor එක අයින් කරාම disease incidence එක අඩු වෙනවා කියන්නේ අපි හොඳ causation බලන්න පුළුවන් factor එක. Generally මේ වගේ ප්‍රශ්නයක් ආවොත් wording බලලා ඕන එකක් හරි කියලා ගහන්නත් පුළුවන් ගොඩක් වෙලාවට. හැබැයි උදාහරණයකට cause must precede the effect කියන එක අනිත් පැත්තට දුන්නොත් ඒක false. Okay. Next one, predictivity of a screening test increases with predictivity කියන්නේ positive අපි test එක මේක අතර බලන්න predictivity. අපි test එකක් positive. If a test is positive. ECG එකක් positive නම් අපිට කොච්චර probability එකක් තියෙනවද ඇත්තටම MI එකක් කියන්නේ. ECG එක අපේ ST elevation වෙනම කතාවක්. අපි ECG change එක අපි දැන් T inversion එකක් වගේ කරා. So T inversion එකකට කොච්චර probability එකක් තියෙනවද මේක ඇත්තටම MI එකක් කියන්නේ. ඒ කියන්නේ biochemical mark එකක් positive. So increase attack rates again ඇත්තටම මේකේ predictivity එකෙන් කතා කරන්නේ positive or negative predictive value of a test. Sensitivity specificity ගැන නෙමෙයි. මම අර positive and negative predictive value කතා කරද්දි කිව්වා it changes with the disease prevalence. Disease prevalence එක වැඩි නම් predictivity වැඩි. එතකොට increase attack rate කියන්නේ case number එක වැඩි වෙනවා because of the predictivity is high. Incidence of illness incidence එක වැඩි වෙනවා කියන්නේ predictivity වැඩි. ඒකයි මම කිව්වේ කොළඹ covid positive වෙන chance එක වැඩි වුණා ඈත පැත්තට වැඩිය. So positive predictive value වැඩි වෙනවා. Prevalence of an illness again prevalence එක වැඩි වෙනවා කියන්නේ predictivity වැඩි වෙනවා. Sensitivity specificity එක ඒක depend වෙන්නේ නැහැ. Sensitivity specificity false. That is the answer for that one. Next one. Okay. Experimental study design. Single blind used to eliminate experimental bias. Generally, single blind අපි කරන්නේ single blind කරන්නේ patients ලා blind. Double blind වෙනකොට තමයි experimental blind වෙන්නේ. එතකොට ඒක false. ANCOVA is used to assess pre-existing difference. Yes, that is true. I mentioned in ANCOVA, we are adjusting for one confounding variable. Pre-existing difference. දැන් අපි බලනවා උස ගෑනුවයිගේ පිරිමියයිගේ. මේ biologically ගෑනුවයි උස අඩුයි පිරිමියයි උස වැඩි. එතකොට අපි adjust කරනවා gender එකට උස කියන එක. එතකොට pre-existing difference එකට තමයි අපි adjust කරන්නේ. අපි බලනවා අස්වැන්න බලනවා එක එක ගස්වල. එතකොට අපි බලද්දි ගස්වල අස්වැන්න බැලුවට අපි දන්නේ නැහැනේ මේ ගහ කොයි අපි ස්ටඩි එකට ගත්තේ කොයි කාලෙද පටන් ගත්තේ කියලා කොයි ලෙවල් එකේද already පළදාව දීපු එකක්ද නැත්නම් අතරමැද එකක්ද ඒතර pre-existing difference එක අපි adjust කරන්න පුළුවන් අනකෝවා. ඒකට ඒක true. Blocking reduce the bias. Generally blocking වලින් අඩු වෙනවා bias යම් කිසි ප්‍රමාණයක් අඩු වෙනවා but blocking අපි පාවිච්චි කරන්නේ confounding variables වලට. උදාහරණයක් විදිහට අපි ගත්තොත් එහෙනම් අපිට කියන්න පුළුවන් one of the example is okay we'll take the same example that is gender with height. We are comparing two groups in relation to height, whether this group is having height එක මේ group එකකට වැඩි මේ group එකකට වැඩි. හැබැයි එක group එකක genders females ලා වැඩි. අනිත් group එකේ males ලා වැඩි. එතකොට naturally මේ group එක අපි practical example අපි බලනවා කොරියාවේ සහ USA වල උස වෙනස බලන්න. එතකොට කොරියාව අපි දන්නවා කොටයි කියලා USA අපි දන්නවා උසයි කියලා. හැබැයි US group එකේ වැඩිපුර females ලා ඉන්නවා කොරියන් group එකේ males ලා ඉන්නවා. එතකොට probability එකක් තියෙනවා කොරියාවේ උස වැඩි වෙන්න. අපි කරන්නේ block කරනවා. block කියන්නේ වෙනම blocks හදනවා. ගෑනු block and පිරිමි block. අපි බලනවා Korean females versus USA females. USA males versus Korean males. ඒ විදිහට බලලා අපිට block කරලා බලන්න පුළුවන්. එතකොට confounding variable එකක් තමයි gender. එතකොට blocking කියන එක mainly focus කරන්නේ bias වලට වැඩිය confounding variables. Confounding variables are threat to external validity of the study. Final can assist the questions. Now, in a research, there are two concepts known as external validity and internal validity. Internal validity is how much we can accept this result within this experiment. Confounding variables, external validity is mostly related to the generalizability. Confounding variables, if there is a confounding variable within the sample, that will directly affect the external validity because answer to 19A false. Those are lateral questions. Now we are talking about external validity. If there is a confounding variable, for example, now Korean USA example, confounding variable is there. When we are trying to generalize the results, the ultimate result will be false. So that will affect to the external value. Can assess causality. Causality can assess, yes. Now experimental study design එකෙන් අපිට causality ගැන අදහසක් ලබා ගන්න පුළුවන්. අපි බලන smoking risk factor එකක්ද lung cancer වලට. ඒතර අපි statistical significance එකක් ගන්නවා. හැබැයි causation ගැන කතා කරන්න නම් මම අර ඉස්සෙල්ලා කියපු coherence, specificity, biological plausibility, temporal association, dose response relationship වගේ ඔක්කොම එකතු කරලා තමයි අපි කතා කරන්නේ. එතකොට causality ගැන idea එකක් ගන්න පුළුවන්, but causality එක assess කරන්න බෑ. ඒ හින්දා මේක false. E is false. Causality ගැන කතා කරන්න අපි කතා කරන්නේ statistical significance එක ගැන. Regarding the studies, cross-sectional studies measure prevalence, true. Case control studies measure incidence, false. Incidence අපි measure කරන්නේ මොනවාද? Incidence කියන්නේ new number of cases. Prevalence කියන්නේ existing number of patients in a given period. Incidence කියන්නේ new cases. New cases identify කරගන්න නම් අපි follow up එකක් cohort study එකක් කරන්න. That is false. A disadvantage of prospective studies is missing followers. Yes. When we are doing follow-up study, we need to plan that carefully. Sometimes we recruit 10, 100 individuals. By the time of finishing the study, there may be only 5 to 10 people remain. So we need to carefully follow up patients. So one of the disadvantages is missing followers. That is true. In case control studies, case selection is by exposure. No. Case selection is by, so we have to forget about the exposure. We only consider cases and controls. Then later only we compare the exposures. Okay, next one. Okay, next one is a cohort study was done to find the association between breast cancer and alcohol. Relative risk is 1.8. Confidence interval is significant, right? I hope why I say so. Confidence interval is significant because the confidence interval does not include the null value 1. Okay, another study was done to find the association between breast cancer and smoking. Relative risk is 1.8, where the confidence interval is not significant. Which of the following statements do you think is true regarding these results? Now, මේකේ දෙකම එකම දේ කරලා තියෙන්නේ. Alcohol වලින් breast cancer හැදෙනවද? Sorry, breast cancer and smoking එකක තියෙනවා. මේකේ හොඳට මතක තියාගන්න ඕනේ මේ alcohol and breast cancer කියන දෙකම මෙතන අහන statistics ම නෙමෙයි, මෙතන medical knowledge එකක් බලන්න. මේකේ medical knowledge එකකුත් බලන්න. අපි දැනගෙන ඉන්න ඕනේ alcohol and smoker both are risk factors. නමුත් අපි හොඳටම දන්න smoking risk factor එක not significant වෙලා තියෙනවා. alcohol එකත් එකත් significant වෙලා තියෙනවා. ඒතර ඒ දෙක හිතේ තියාගෙන තමයි අපි answers වලට යන්නේ. Both are risk factors for breast cancer. That is ඒක true අපේ knowledge එක. But according to the results ඒක true වුණාට ටිකක් තමයි ඒක true. මොකද ඒක smoking කියන එක නෑ. අනිත් එක තමයි best answer type එකේ ගොඩක් වෙලාවට සමහරවිට පහම හරි වෙන්න පුළුවන්. ඒකේ හරියටම හරි එක තමයි අපි ගන්න ඕනේ. Smoking is a risk factor for breast cancer. Yes, it's true, but according to the results, it's not. ඒකත් හරි නමුත් ඒක වැරදි. Alcohol is not a risk factor for breast cancer. ඒක අපිට කියන්න බෑ. Both associations are due to bias. එහෙම එකක් අපි කියන්න දන්නේ නැහැ. The sample size of the second study likely to be small කියන එක තමයි මගේ answer එක. The reason is smoking is a non-risk factor. Smoking is a non-risk factor, but the result is not statistically significant. That means if you go back and recall your type 2 error, it's most probably due to type 2 error. අපි හොඳටම දන්නවා මේක risk factor එකක් කියලා, නමුත් study එක not significant. ඒ කියන්නේ type 2 error එක. ඒ හින්දා in order to minimize type 2 error, we increase the sample size. So the answer should be E. That is my answer. Next one. That is again we can even skip. Study was carried out to determine value of investigation, which was planned to be used in the screening of a certain disease. The new test was compared with the gold standard investigation for diagnosis of disease population of 400. right මේක ගණන් හදලා ගන්න තියෙන්නේ මම හිතන්නේ උත්තරේ එන්න ඕනි උත්තරේ A වෙන්න ඕනි මේක best choice එක. මොකද the prevalence of disease relevant population is 0.5, that is altogether 400 people. Gold standard positive means total disease people, the total is 200. Because of that 0.5, that is the prevalence. All the other values you can calculate and which are wrong. The answer is A. Okay, the next one. Okay, thank you very much. So all the MCQ that I have is finished. And first of all, let me give thanks. So this is the 100th episode of this kind of program. I have done this. Generally, I do this like as three different sessions. But today I had to do this as just one session. And I'm sorry for keeping this much of time. And thank you very much for participating and registering. Of course, there will be another session in next 1 or 2 weeks time. Because of that, today's now we are doing trade union action. Many of the participants have participated for this trade, all these protests and all in Colombo. I will do that in another thing. If you have more questions, now I can take up. All the others can leave. So you can comment. We can discuss this if you have more questions. If you don't have questions, so if you don't want to stay, you can leave right now. You can comment, you can give feedback. We will share one session with you. If you have participated, you can share as well. Okay, so if you have questions, we can go. There are few in the chat box. Please explain the Z test. Z test is almost same as T test. We can use Z test. So give me 1 second to explain about Z test. So I mentioned T test. Generally, Z test is we are talking about the Z distribution in Z test. But T test is slightly different from the Z distribution. This is T distribution and this is Z distribution. Z distribution is the standard normal distribution. All the places where the sample size is high, when we increase the sample size, this T distribution will take the shape of standard normal distribution. T distribution will take the shape of standard normal distribution, right? Then, when the sample size is increasing, instead of T test, we can go for Z test. That's all about Z test. If you really need the calculation, Z equals x minus x bar divided by standard deviation. Now in your A-level physics, if you have got 75 marks and all island mean is 45, and assume that the standard deviation is 15, that is 30 divided by 15, your Z score will be 2. Your Z score will be 2. Again, that means in normal distribution, if your Z score is 2, means you are at 2 standard deviation position. That means only 2.5% of the students are having marks more than you. ලංකාවේ 97.5 වෙනි ස්ථානයේ තමයි ඉන්නවා Z score එක 2යි. So that's all about Z score. We'll see whether we have more questions. Thank you and screenshot is there. I don't know whether I can open it. I don't think that we have time to discuss the essay questions. So please send me an email specifically to answer these essay questions. I'm sorry for that one because we don't have time to discuss essays right now. With extremely sorry. And I all the best for the exams. Tarindu Chandika had some different, yeah. Tarindu Chandika, okay. Can we have stems for previous discussed MCQ slides presentation? Some MCQ stem didn't get. Thank you, sir. I don't know which stems. What you can do is you can just WhatsApp the question. I will send you the answers. And we past papers come out statistics. මම දැක්ක මේන් එකක් තමයි වැඩිපුරම incomplete stems තියෙන statistics. ඒක කවුරුත් ඒක කරපු අය දන්නේ නැතුව හරි වැරදි stems තමයි ඇවිල්ලා තියෙන්නේ. මේක generally එහෙම වැරදි stems තියෙන්න බෑ. ඒකින්ද එහෙම ප්‍රශ්නයක් තියෙනවා. Smith, please send me an email. Unfortunately, I don't know your name. Okay, there are. Okay, so that's the end. Thank you very much for participation. Still 90 people are remaining. I expected only about 60 to 100 people. Even at the end, remaining 100 is a significant number. Thank you very much. I hope you got something. And thank you very much. If you have more questions, I will wait for another few. Okay, the recorded lecture, we stop recording now. And we will edit that. Give me about 2 to 3 days. I will